academic and intercultural level. Significant progress towards solving global challenges cannot be made without our respective contributions. China has been and will hopefully stay an important cooperation partner of German universities and research organizations. Travel restrictions during the pandemic bear heavy on the academic exchange. The past years, it has been very difficult to develop new cooperations. But when it comes to climate change, this is very important. We cannot rest, but need to move on quickly. I want to thank the organizers and speakers of today's event. Thank you for your time and your support. I wish everybody in the audience will enjoy the presentations and be motivated to join the scientific community pursuing the SDGs. Welcome and thank you for your attention.
Thank you very much, Ms. Szymanowski, for your wonderful remarks. Next, let me give the floor to Professor He Lianzhen, Vice President of Zhejiang University.
Thank you. Dear Ms. Szymanowski, Professor Haber, and Professor Auer, distinguished professors, colleagues, and students. On behalf of Zhejiang University, I'd like to welcome you to the second Sino-German Sustainable Development Forum, jointly organized by ZGU, RWTH Aachen, and DAAD China. We are privileged to bring together eminent speakers from China, Germany, and other countries under the theme of Empower SDGs with Green Building, which is a pressing and pertinent issue for the world. This year marks the 50th anniversary of the establishment of the diplomatic relations between China and Germany. As the two nations are furthering cooperation in confronting global challenges, higher education institutions and the related stakeholders have a crucial role to play in promoting prosperity and protecting the planet. As a traditional component of our global engagement, we enjoy a long history and a solid foundation of interactions with German universities, and we are keen to scale up collaborations with German partners around sustainable development. In March 2021, Zhejiang University launched its Sustainability Action Plan, a global ZGU for social good, also shortened as Z4G. This plan serves as a blueprint to improve sustainability-related education, research, and practices, not only within ZGU, but in the wider community, home and abroad. In the same line, today's forum will be another important step under the umbrella of Z4G, which seeks to mobilize the broad support from the UN's 2030 Agenda. At first glance, buildings seem to be inanimate structures, but as researchers point out, buildings actually represent a complex factor contributing towards multiple SDGs, such as sustainable cities, clean energy, health, and well-being. In green buildings around the world, we see an opportunity to not only save energy or reduce carbon emissions, but also to educate youth, create jobs, strengthen communities, and so much more. With this in mind, I believe today's forum will help us nurture new links in civil engineering, architecture, and relevant areas, foster friendship, inspire innovation, and contribute to a more inclusive, sustainable, and resilient future. I hope you will enjoy the upcoming sessions and benefit from the information and insights given by our distinguished speakers and participants. Thank you, and I wish the forum a great success. Thank you.
Thank you, Professor He. Now I would like to invite Professor Woote Haber, Vice Rector for International Affairs, RWTH Aachen University. Welcome.
Good morning and good afternoon. Dear Professor He, dear Professor Fung, dear Dr. Szymanowski, and dear colleagues, participants, and guests of the second Sino-German Sustainable Development Forum. First of all, I would like to take this opportunity to thank Zhejiang University for doing the lion's share to organize this event, and especially also for allowing us as RWTH Aachen University to be co-organizers this year. We appreciate this opportunity. This forum, so I think, is a wonderful opportunity to jointly advance the importance of international cooperation on one of today's most pressing issues. According to United Nations figures, and we have heard it before, the construction and operation of buildings is responsible for 38% of global greenhouse gas emissions. In Germany alone, the construction industry produced 4.3 million metric tons of CO2 equivalents in 2019 and consumed 1/3 of all resources. In recent years, the construction industry has seen a tremendous surge in innovation, but there is consensus that more effort needs to be made as soon as possible so that we can leave a livable environment for our future generations. As scientists, we have an obligation for both: to provide political decision makers with arguments for improved construction policy, and through further innovations to open up perspectives and concrete opportunities for both business and society to manage, build, house, and live more sustainable. In its sustainability mission statement, RWTH Aachen University promotes a clear understanding of sustainability across all areas of the university, encourage all of its members to commit to sustainable action, and foster dialogue on the topic of sustainability. So sustainability has become the focus of attention within our university. At the same time, our mission statement helps RWTH Aachen to actively position itself and can be used when communicating with external partners in research, in industry, and in society. To quote from the statement, "Only together can we make the best possible contribution to shaping science and society for the future in a lasting and reliable way. We, as RWTH Aachen, are fully committed to reaching this goal and using the network for all this." I see this event as a building block for living up to this claim. I wish all participants a lively exchange and successful cooperation for the advancement of all our efforts to improve the building construction sector in this respect. Thank you very much for your attention.
Thank you very much, Professor Haber. Now let's welcome our last but very important speaker of the opening session, Professor Thomas Auer from the Department of Architecture, Technical University of Munich. Professor Auer is partner of Chancellor Stuttgart. In both education and research, he focuses on sophisticated design tools and strategies for climate-responsive and energy-efficient building design. Professor Auer will bring us a keynote speech entitled High-Tech, Low-Tech, Robust. Welcome, Professor Auer.
Yeah, thank you very much, ladies and gentlemen, thank you for the introduction, and thank you for the invitation. I think it's a great pleasure for me to be here today to join this forum and to talk about our visions and idea of how we can decarbonize and contribute to a much more sustainable building stock. So we already heard the building sector has to become carbon neutral. In Germany, the goal is to be carbon neutral for the entire building sector by 2045. This is very ambitious. It's addressing basically two aspects. The one is building operation, and the other one is construction. Construction like material use for new construction, but also for renovation of the existing building stock. Let me start with a project I worked on before I became professor at the Technical University of Munich. There was a very ambitious project in Canada for Manitoba Hydro, together with KPMG architects from Toronto, and Manitoba Hydro, a utility company in Canada, had the vision to build the most energy efficient high-rise building for 2,000 employees in downtown Winnipeg. And so we started to work on this project and analyze climate. So our profession, what we call it climate engineering or climate responsive design. So there is a thorough understanding of climate conditions is the basis for our work. And we recognize that Winnipeg is a very cold climate with temperatures going down to minus 35 degrees in wintertime, but in summertime going up to plus 35. But having a lot of solar exposure, Winnipeg has more solar exposure on a horizontal surface than any location in Germany, more than the city of Milan, almost as much as the city of Rome. So there was this general idea or approach of a passive solar design where we ended up with an 18-story tower on a 3-story podium. And we divided the 18-story tower into three 6-story packages, or we called it neighborhoods. And each neighborhood had a south-facing winter garden. And we used the winter garden as a lung for the building so that we supply the air at 10 degrees. So we condition the winter garden only to 10 degrees in winter. So then when the sun hits the winter garden, it heats up the air before we distribute it by a raised floor plenum into the depth of the floor plate. And on the north side of the building, we take it down into the basement where we have a heat recovery. We have a radiant system for heating and cooling purposes, which is embedded in the concrete slab of the buildings, of the individual floors. We have a solar chimney that runs natural ventilation. If we don't need heat recovery, there are almost 300 boreholes going down about 120 meters under the building, creating a geothermal heat exchange, which is operating the radiant system for heating and cooling purposes. And then to the east and to the west, we do have double facades to control the climate, to enable natural ventilation, etc., etc. So this is the south-facing winter garden. So this is basically the mechanic room of the building. Under the benches on the right side, there are the units that supply the air into this south-facing winter garden, where it acts as the solar collector. And then behind the panels on the left side, there are the units which take the air from the winter garden and distribute it into the offices. As I said, to the east and to the west, we do have a double facade to control these extreme conditions in winter, but also in summertime, having the shading device, such a Venetian blind, integrated into this facade cavity, allowing for natural ventilation, but also having this shading device outside the conditioned space, which is much more efficient than having an internal shading device. It also has a couple of advantages with regards to building physics. So all of this led to the fact here, MNECB was the code requirement in terms of energy consumption when we designed the building something like 15 years ago. And the 88 kilowatt hours per square meter a year was our prediction by computer modeling. So by computer modeling, we modeled that the building is something like 60–70% better than minimum energy code standards in Canada at the time. And then when we started operating and monitoring the building in 2010, in the first year when we had full data, we recognized that the first year of operation, we had a performance gap of almost 100%. So the building, in fact, used almost 100% more energy than necessary. And it took us indeed almost 2 years until the building operated as designed. There was not one problem. It was more like a long list of smaller issues like sensors, which were not installed or showing the wrong value, things like this, or routines, which are, let's say, programmed the wrong way. So it was a long process of fine-tuning and optimizing until the building worked as designed. This was a bit frustrating. The building still works very well and still considered very successful. The client is very happy still with the building. But the question was driving us also at the university, this question of performance gap. Is it a specific issue of the construction industry? And we did some literature research, and we found a couple of studies. One study here is from the Royal Institute of British Architects, and they found that in all over Europe, 60,000 school buildings, out of 60,000 school buildings, 95% did not perform as intended. And then we found another study from the TU Braunschweig. They figured out that modern office buildings in Germany do have an average performance gap of 70%. So the Manitoba Hydro problem was not let's say, a specific problem of Manitoba Hydro only. It seems to be indeed a problem of the industry. And the question is, how can we get much more quality control into the industry? Or the other question, is the model too complicated? Is it, given the fact that we do have in Germany, we do have 21 million buildings, do buildings need to be much more simple, much more robust to achieve our ambitions in terms of energy savings and carbon reduction? And this is something we started to dig deeper into our research at the university. And we did a study on schools, which was published in this book by the DAAD Verlag in Germany. And I called it Learning from Heritage. We looked at 12 different schools together with the chair of Florian Nagler, a colleague at the TU Munich. Schools from different decades, starting with a school on the upper left side, which was constructed in 1898. So more than 120 years ago, and then all different decades, all the way down to the building on the bottom right side, which is designed by Florian Nagler himself. It's a timber school. It has won the German Timber Award. It was a research project aiming for the highest energy efficiency in school building, in school design. And so we did measurements in all those 12 schools, looking at environmental qualities, but we also looked at the overall energy performance. What we found is, so this is just a short, extremely short summary of a very thick book. This is the Theodor Fischer School from 1898, 120 years old. This school has 80 square meter classrooms instead of 60 square meters, what we do today. It has a 4 meter floor to ceiling height instead of 3 meters. So this provides almost twice as much air volume per person in a classroom compared to what we build today. Now, the interesting result was that among all buildings, among all schools without mechanical ventilation, we had the best air quality in this building. Among all schools without mechanical cooling, we had the best comfort in summer just due to the thick walls they built 120 years ago, and not even having an external shading device. Among all schools, we had the best most even daylight distribution with the lowest fenestration ratio. So we had the smallest windows just because the windows are so tall, because the space is so tall. And even in terms of acoustics, the result in terms of reverberation time was very good because of these big curtains that are used for daylight and glare control. So we had really extremely good results. I said, today's research, we would call it multi-objective optimization. But 120 years ago, it was common sense of building design. And if we look at the mechanical rooms, the Theodor Fischer building has a boiler room of 30 square meters, whereas in the Diedorf school, they built a gym under the building to house all this mechanical equipment we use today to provide environmental quality and energy efficiency. And so thinking about maintenance quality of our public buildings, again, on the upper left side, the Theodor Fischer School did not go through a major renovation within 120 years. Those systems use a lot of maintenance. And as I said, it was a research project. It took them 3 years to operate the building as designed. So we need to question whether this is a role model, thinking about the amount of public buildings we have. If we need these mechanical systems on the bottom right side as a rollout model, think about how many of maintenance people only we would need to operate those systems properly. Thinking about performance gap and all the maintenance requirements. So this already shows us that we need a different model, a model that is more simple, a model that is more robust, and a model which we learn from Theodor Fischer. So we started this research project we called Einfach bauen, or build simple and robust. And we had a couple of, let's say, headlines. It was a research project with many chairs from the TU Munich involved, but also industry being involved. And one of the headlines was, we want to use just no composites, just pure materials. It has to be accessible. Everything needs to be exchangeable also over time. And we looked at details and said, can we simplify not only on a mechanical side, but also on a construction side? So today, if we do a concrete wall or a concrete construction, you see the section on the left side. This is how we would build a concrete construction or concrete wall. We would glue insulation on top of it, already very difficult to separate later at the end of life. And then we have a shading device, which creates a cold bridge. We have a floating screed, which we mainly use for hiding all the installation, piping, electrical, etc. below. And the question was, can we get from such a section, applying the Theodor Fischer principles, to the right section, using insulating concrete? The same we did for timber, the same we did for insulating brick. And then we did a parametric study where we see the importance of height in terms of performance, because as taller a space is, as more narrow and taller a window becomes, providing with a low fenestration ratio, daylight deep into the space, and then we need a lower fenestration ratio, avoiding the need of shading devices, etc., etc. So we ended up with 81 geometries, 4 orientation, 3 different building materials, three different glass types with 4,000 options or variants, looking for the optimum. And then the B&O group from Bad Aibling found it so interesting, our research, and built those 3 buildings, one out of concrete, insulating concrete, one out of timber, and one out of insulating brick. And as I said, no composites of materials. I go fast over it. These are the floor plans. We kept it all simple. We kept all the installation exposed. Here you see the concrete building. If we don't have a floating screed, then you suddenly see the piping for the radiator exposed. And then the electrical wiring at the bottom, also everything exposed, but accessible and exchangeable over time. And here you see the brick building. And here you see again with the floor to ceiling height of 3.10 meters instead of 2.50 meters, what we build today in housing. You see that with a fenestration ratio of less than 15%, the very good daylight quality we achieved in those buildings. So those are the 3 buildings which won the German Nachhaltigkeitspreis award for sustainable construction and many other awards. So this is, we are going to extend this for student housing in Munich. You see the bigger roof on top. This is mainly to maximize PV power generation on the roof, or one of the reasons, so that we get close to net zero also with this approach of simple and robust. And so let me conclude. The decarbonization of our built environment is a huge challenge. However, it's also a big opportunity, but we have to design it. And then models need to be simple and robust. Thank you very much.
Thank you so much, Professor Auer, for your inspiring speech. And thanks again also to all speakers for your inputs. And next, we're going to hold 3 parallel academic sessions, which run simultaneously. Participants of parallel session 1, please stay in this Zoom webinar. Participants of parallel session 2 and 3, please check your email or this webinar's chat box for the corresponding link to join. After the parallel sessions, please return to this webinar arena for the funding opportunities session and the final roundtable discussion. I hope you will all enjoy the rest of the forum and look forward to a fruitful event. Thank you. Professor Zhao Yuxi, now the floor is yours.
Okay, thank you. Thank you, Professor Zhang. Thank you. Shall we start? Hello, Professor Xiao.
Hello.
Yeah,
Nice to meet
okay.
you, Professor Zhang.
Okay, so shall we start now, Professor Xiao?
Yes.
Okay, let's start this session. Okay, good morning and good afternoon, dear colleagues and students. Very welcome to this session, session 1, low carbon concrete structures. I'm Yuxi Zhao from
Can I begin now? Can you hear me?
Yes.
Recording in progress.
Can you hear me?
Yes, we can hear you.
Yes.
Okay. Okay, let me begin now. So, good morning and good afternoon, professors, colleagues, and friends. Welcome to the session 3 of the second Sino-German Sustainable Development Forum. So I'm the chair of this session, and I would like to briefly introduce myself, okay? My name is Zhejiang. I'm from a College of Civil Engineering and Architecture at Zhejiang University. My research interests comprise mainly about polymer mechanics, concrete durability, and CCUS, technologies for civil engineering applications. So today we are honored to have distinguished scientists in the field of low carbon materials and life cycle assessment. I believe that they will show the greatest research work, and their research will shed much light on low carbon construction materials in different aspects. Okay. I have to say that the speaker first make the speech one by one, and this may cost 1 hour. And after that, we have about 20 minutes to ask questions and give answers, okay? So I have to emphasize that each speaker only have 15 minutes for speech, and I hope that every speaker can strictly control the speech time. Okay, now let us warmly welcome the first speaker, Professor Si Caijun. Professor Si is a chair professor of colleague and civil engineering, Huang University. His research interests include the characterization and the utilization of industrial byproducts and waste material design and the testing of cement and concrete materials, development and evolution of cement additives and concrete admixture. He has authored more than 470 technical papers and 7 English books, 3 Chinese books, and edited 7 international conference proceedings. His Google Scholar citation is over 27,700. And his H index is 87. Okay, so today professors will talk about the design and the property of ultra-high performance geopolymer concrete. Okay, professors, it's your time.
Okay. Thank you, Professor, and thank you for your kind introduction. And colleague, and yeah, my name is Caijun Si from Huang University. And so today I'm going to talk about the design and the property of ultra high performance geopolymer concrete. The outline of my presentation. And probably a lot of people know about a geopolymer uses solid waste as a main component plus alkaline activator, and so the production mainly solid waste and this oxide, and well, actually there have been a lot of applications, and well, in the former Soviet Union, and also recent years, while in Australia, they use the geopolymer concrete to cast the runway of airport, and also build a building in Queensland, was the University of Queensland. And recently, another very hot topic is ultra high performance concrete. And compared with the conventional concrete, ultra high performance concrete has very high compressive strength, usually higher than 120 megapascal. And actually, recent years in China, we have used this to build a lot of infrastructure, and also actually in US and in Europe, they also have been widely used for different infrastructure construction. Well, come to geopolymer concrete, during past several years, we have established a relationship between the chemical composition of the precursor and the setting time and compressive strengths. So this gives us a good guideline how to select the precursor and to design the proper binder for the construction purpose. And while the other situation actually have been both research is about the setting time of alkali activated material, especially slag-based geopolymer. It has very quick setting time. And so here we combine three types of chemical activator, basically sodium silicate, sodium carbonate, and sodium hydroxide. So by combining this to 10 hours, even, you know, so it should be
Hello, Professor Si. Hello. There may be an internet problem. Hello, Professor Si.
Yeah.
Hello. Hello, Professor Si. I can see your screen. Hello, Professor. Can you hear me? Okay.
Hello, can you hear me now?
Yes.
Oh, okay, sorry. Yeah, the internet is not stable here. And
Okay, you can go back your
Okay, so
presentation.
we also established a relationship between the composition of chemical activator and the strength of the material at the different ages. So in that way, we can design the required materials very easily based on the combination of those activators. And so based on all those procedures, we also come up with a flow chart of the mixture design. So basically, from the material selection and then determining of the aggregate proportion based on plucking density, and then determining of the paste content based on the excess paste theory. And so then analyze the parameters, then establish the relationship between the composition and the property of the material using Takeuchi method. And so finally, we could get the mixture design as we want. And so actually, this is a closed packing theory. And so this is a formulation to calculate the solid void volume of the mixed aggregate. So if we assume all the aggregates are spherical or square, then we could calculate the surface area of those aggregates. And in reality, those aggregates are not spherical or cubic. So then we multiply the shape factor, and so finally we could calculate the excessive paste thickness of the excessive paste. And so then we select several factors: water bind ratio, fly ash to bind ratio, and also excessive paste thickness. And this is activator to bind ratio, the modulus ratio of the activator. So then we could establish a relationship between those parameters and also K-value of the slump. And so finally, we could get the strength chart of the mixture design. So this is water bind ratio, and this is slump of the concrete, and this is the excessive paste thickness. And so then we could get those relationship line also from those charts. So based on this flow chart, we could see, very easily, if we want to get strength greater than 80 megapascals, so water bind ratio should be, between 0.35 to about 0.4, and so the activator to bind ratio is higher than 6%. And so based on those design principle, and so then we designed the binder composition for ultra high performance geopolymer concrete. So here, definitely, so the water binder ratio should be less than 0.34. And here, actually, we also should use enough fly ash to improve the threshold property. But in reality, in further to reduce the initial porosity of the mixture design, we also should use some silica film. So this actually ternary components we used for the design for ultra high performance geopolymer concrete. So basically fly ash, slag, and silica film. And so actually, when we use different modulus of walt glass, so then we could get the flowability of those mixture designs. So we could see, from the modulus of ratio from 1 to 2, and we can all get flowability about 200 millimeter. And so then we measure the setting time of those systems, and so we could see for the initial setting time, so we could easily get initial setting time of 2 to 3 or 4 hours, and then for the final setting time, typically it's about 4 to 6 or 8 hours, and so this should be long enough for construction operation. And so then we measure the strength, and here we, based on the different mixture proportion, we got the water absorption and also water absorption porosity of this mixture. And so then based on the different water absorption porosity, we also got the corresponding strength of those mixtures. So you could see we can easily get strength about 100 megapascal. And so here, if we overlap all those ternary diagram, and if we want to get flowability over 210 millimeter with initial setting time of greater than 2 hours and compressive strength higher than 90 megapascal. So actually, this is the yellow composition range of the composition that can meet this performance requirement. And so now we want to have a further look or understand how silica film act in the mixture. And so here, initially, we examine the rheology property of those mixture with different contents of silica film. So you can see when we add silica film, from a 5 to 20, even 30%. So definitely from a 5 to 20%, especially about 20%, it gives the lowest yield strength. And also we measure the heat of hydration. So we could see, well, the addition of silica film does have some effect on the initial heat evolution. And so we also examine how silica film behave in the microstructure. And so we could see, from 30 minutes to 28 days, or even after 1 day of steam curing, we could see, some silica film still exist in the spherical form, but some of them are dissolved from the surface. And so we analyze the composition of those hydration product. We could see easily two types of product. It's cash and nash here, and depends on hydration time. And so this aluminum to silica ratio basically range within certain range in the. And well, we also measure the mass variation after selective dissolution. So we could see, after 1 day and of hydration, or 28 days of hydration, so quite a lot of silica film actually reacted, but still a lot of silica film are not reacted. So then we also use the infrared spectrum and to examine the original mixture and also the undissolved species in the residue. And so we also could see, a lot of silica film are not chemically reacted. And so we also measure the quantification of NASH and also the unreacted slag in the system, and based on this infrared spectrum. And so we could see here unreacted slag, from the silica film content from 0 to 5 to 10%. So it has slightly changed, but on the other hand, the NASH content seems increased as the silica film increases. And also we measured the composition, or examining the post-solution. We could see that effective information cannot be acquired from the FTIR spectrum of the residue after the selective dissolution. This is the spectroscopy of the residue with 0 and 10, also 20% of silica film addition. So we also could see, there are quite different for those silica film, and especially after different time of hydration, and the remainder silica film are also very significantly different. So this is the TM examination of the silica film from the matrix. So we also still could see, a lot of spherical balls or silica film, in the system.
Professor,
so,
only 1 minute left. Only 1 minute.
Okay, so here we're going to say also the steel fiber factor. So we use a different type of, a different shape of steel fiber. So the addition for steel fiber decreases the flowability, and but on the other hand, increase the strength from 100 megapascal up to 160 to about 180 megapascal here. And so this is the flexural strength. So we could see, we use different fiber content, and so it increases the flexural strength very significantly. And so this is actually with 3% steel fiber. And also we are examining that with different type of different ratio of steel fiber, deformation ratio. And this is a comparison of ultra high performance geopolymer concrete with normal ultra high performance concrete. So we could see there are quite a bit of difference. So actually, finally, because of time difference limitation, I will skip those slides. But I want to show you actually the cost comparison between these two mixtures. This is a normal ultra high performance concrete. It costs about 1900 RMB per cubic meter. But on the other hand, for ultra high performance geopolymer concrete, it costs only 1,300 yuan. So, the cost is about 30% less. The main reason is for ultra high performance geopolymer concrete, we still do not use cement, and also we do not use super plastic size. And so finally, I want to conclude. So basically, with proper design of the composition, we can get a very good performance, ultra high performance geopolymer concrete, and the cost is significantly lower than the conventional ultra high performance geopolymer concrete. Thank you for your attention.
Thank you, Professor. This is a very nice talk. Okay, Professor, don't leave now. We may have a discussion later after we have a fourth speaker. Okay. Speech. Okay. Okay, now we go to the next talk by Dr. Ruan Shaoqing. Dr. Ruan Shaoqing is an assistant professor in Institute of Building Materials and the State Key Laboratory of Clean Energy Utilization, Zhejiang University. Dr. Ruan has published over 40 peer-reviewed scientific papers with citation over 1,000. And he has published 2 invited chapters, 1 PCT patent and 1 Chinese patent. He is the PI or co-PI of several research funding from National Natural Science Foundation of China, Natural Science Foundation of Zhejiang Province, and the Key Research and Development Plan of Zhejiang, as well as Guangxi Province. Okay, today Dr. Wang will talk about research progress in sustainable engineering materials towards carbon neutrality in Zhejiang University. Okay, Dr. Wang, it's your time.
Okay, thank you. Let me share my screen first. Okay, thanks for the organizers, and thanks for Professor Zheng. So today my research, my topic is about the research progress in sustainable engineering materials in Zhejiang University. And I'm from Institute of Building Materials. It belongs to College of Civil Engineering and Architecture, Zhejiang University. So as we know, China has already set these climate-related goals. That is, by 2030, we should reach a goal of peak carbon emission. Then by 2060, we should reach a goal of carbon neutrality. So, which means we should try our best to reduce the carbon emission. However, concrete is one of the largest sources for carbon dioxide, and irrespective of its raw materials mining or cement manufacturing or concrete mixing, these activities all emit a large amount of the carbon dioxide. So we should try our best to reduce the carbon footprint of these activities or procedures during the concrete preparation. So here comes the question. So how to increase the sustainability of concrete while still maintaining its high performance. So in our institute, several actions have been taken, or several attempts that have been done. It can be divided into 4 categories. The first is the binders, and the second is the aggregates. We try to use low carbon binders or low carbon aggregates to reduce the carbon footprint of the concrete during its preparation. The third attempt is we try to use some high performance admixtures, or we try to enhance the durability of reinforced concrete to enhance their durabilities, which means it can save materials and reduce the carbon emission during concrete preparation. And to be more specific, in terms of the low carbon binders, and geopolymer or carbon fixation concrete have been developed in our institute. And in terms of the aggregates, the recycled concrete aggregate, which is mainly the cross aggregates, or the machine-made sands, which is from the acquisition of the mining. Then when it comes to the other mixtures, Professor Lai, she's working on the super absorbent polymer, which is the SAP for short. And meanwhile, in terms of the reinforcements, Professor Yang Dongming is working on the coated rebars, and I will introduce this one by one later. Then first, in terms of the geopolymer, Professor Shi is also introduced some about this before. And as we know, geopolymer, it contains several types of the wastes, or we call these precursors. And various precursors of geopolymers have been tried and studied separately in our institutes. It contains fly ash, or metal cutting, or rice husk, or coal gangue. Meanwhile, we also use some alkaline activators, such as the water, glass, or sodium hydroxide, or potassium hydroxide, and different properties, such as we try to investigate the proportional design theories, alkaline equivalents, and modulus of alkaline activators. The setting time, the compressive strength, the flexure strength, and the splitting strength have all been studied. Meanwhile, the control relationship between the microscopic modulus, hardness, and creep behavior, and the pore size in the microstructure has also been confirmed. In addition, the performances of geopolymer, these are made from the wastes in a harsh environment, have also been investigated. For example, the pore structure under the freeze and thaw cycles has been optimized. Meanwhile, we found that is the volume stability of geopolymer concrete still keeps excellent after the sulfate attack, and the calcium-containing raw materials that weaken the chloride ion penetration rate. And meanwhile, some geopolymer can also be used as the waterproof materials, composites, which provided different performances in water and ion transport properties. In addition, that is, we also try to prepare the metal cutting-based geopolymer, and the high-strength metal cutting-based geopolymer have been provided, and it shows very ultra-high strength since day one. So these studies, or these outcomes, confirms the geopolymer has excellent performances even in a harsh environment. Then we also, performed some research regarding using the geopolymer to prepare 3D printing. And after some properties such as the yield stress or viscosity of geopolymer have been tailored, they can be potentially used in some low carbon structures, which is quite interesting. And we collaborated with the NTU in Singapore. And the second part is about another low carbon concrete. That is, we call this the carbon fixation concrete. And this piece of research is also quite interesting. And we also collaborated with Singapore. And we, as we know, in some countries like Singapore, they are short of the pure water. So they try to use the seawater to provide the daily water. So that means during this process, it will produce a lot of the reject brine, which is rich in magnesium ions. But this reject brine may directly do harm to the marine creatures. So we try to recycle this reject brine. So we try to use this reject brine to synthesize the magnesium oxide or MgO. Then this MgO can sequestrate the carbon dioxide to provide high concrete strength. This concrete did not use any OPC. So which means this concrete can sequester CO2 to be hardened, and this carbon dioxide can be permanently stored in this MgO-based concrete. Then another attempt is, in Canada, they have a very famous company that is called the Carbon Q. During this process, the waste carbon dioxide emissions are collected from the local industrial emitters by gas companies and be purified. Then, this carbon dioxide will be stored on site, and they will react with the carbon dioxide during its mixing. And finally, this carbon dioxide have been permanently stored in concrete. And in our province, last year, we collaborated with the Zhejiang Building Materials. It's a very big company in Zhejiang, and we tried to develop the carbon fixation concrete and some new equipment, some ready-mix concrete, and panel walls will be developed in the future. And hopefully we can prepare some concrete that is with the greater carbon dioxide sequestration, and it also shows excellent strength and durability. And as we know, durability is the issue. It could be an issue in this concrete, as the carbon dioxide, the reaction between the concrete and the carbon dioxide may lower the pH, and it may do harm to the durability. And this is our focus in the future. Then the second part is about the aggregates. And normally people use the concrete aggregates, recycled concrete aggregates, to be used in the concrete preparation. And in our institute, we try to use some waste brick, and it combines with the normal concrete and to provide the aggregate profile. And the second picture, we can find that is the construction of the weak area, and it shows the waste brick. The use of waste brick may lower the strength of concrete. And the third picture is about a model. We try to propose a model to simulate the diffusion of chloride ions within the recycled brick concrete. The third part is about the superabsorbent polymer. And actually, this is not new. But we try to synthesize a new SAP that is with the low-grade kaolin. The low-grade kaolin normally is waste, and we try to recycle these wastes. And actually, if we use the SAP in concrete, and because it is polymer, so sometimes the overall strength will be reduced. So this, in terms of this, we try to synthesize this new SAP low-grade kaolin, and hopefully it will not sacrifice the strength. And the second picture is about the chemical formula and the morphology of this new type of the SAP. And the third picture is about shows that the synthesized SAP could reveal a very good water absorbency. And the third picture, it shows the SAP could greatly reduce the concrete shrinkage due to its expansion. Then it's about the rebars. Actually, in terms of the durability, we normally the reinforced concrete is of paramount importance, and we try to use the animal coated rebars, as we can see in the picture in the bottom. And the first picture is about the porosity in the interface zone. The second picture is about the bond slip curve. Then the bonding mechanism and the bond failure mode are also provided. And as we can see from these images, the porosity in the interface zones, we can see that the lower interfacial porosity can be seen. Meanwhile, as we can see from the second picture and the second picture, the bond slip curve, and the third picture, the bonding mechanisms, we can find that is stronger CRE rebar bond stress can be found. So, which means after we use these CRE coated rebars, the overall the bonding behaviors of the steel rebars can be greatly improved, which means it can improve the overall durability of the reinforced concrete and saves the materials in the future. That's the left picture is the animal coated rebars, and the second picture is about the corrosion behaviors using the animal coated rebars. And the first picture is which you can see is the early immersion. And if we use this when these ions are in the corrosive, when these steel rebars are in the corrosive medium, then the rust expansion and the coating under compression begins. And the third picture is about the later immersion and the coating intact and the rust compacted and the high strength. And all these pictures reveals that the corrosion can be alleviated if we use the animal coated rebars. And thanks, this is my short presentation, and this is my email and Google Scholar page and ResearchGate page, and this is my WeChat. Okay, thanks.
Okay,
Finish.
thank you, Dr. Ran. Oh, it's a nice presentation. But due to the time limitation, we need to fast move to the next talk. Okay. So so we go to the set talk by Professor and Dr. Matthew Trevsel. Professor Matthew Trevsel is full professor and head of chair and Institute of Sustainability in Civil Engineering in RWTH Aachen. She works in the field of life cycle assessment and sustainability performance of building and the transport sector and the strategic environmental assessment to the transportation urban systems. Professor Trevsel is the founder of a non-profit organization, ISUD, Information for Sustainable Development, for disseminating sustainability concept among Italian consumers. President of Direct Board of the Forum for Sustainability Through Life Cycle Innovation, FSRCI, and the chair of Global Listening Center. She is also a member of the advisory board of Modest Foundation. Today, Professor Trevsel will talk about ecological assessment of carbon concrete. Professor Trevsel, please start your talk.
Thank you for the introduction. Can you hear me? Can you hear me correctly?
Yes.
Yeah, very good. So thank you for the introduction. I'm happy to start the presentation. I share my screen.
Yeah, okay.
Hopefully works properly. Then you should be able to see it. Okay, so I will give you a relatively short introduction on what is life cycle sustainability assessment and what we are doing. And then I will go directly to an example, of our work around the carbon concrete, and also in particular the comparison between carbon and steel concrete, so to see which are the opportunity to improve the CO2 equivalent emission. As we know, the construction sector play a significant role in reducing the opportunity to reduce actually the energy consumption, environmental impact, because it's responsible of today of the 32% of global energy consumption, is quite important also for around 20% for the total global greenhouse gases emission and even more. And of course, it's important also for the global consumption of raw materials. So all of these are important environmental impact that must be absolutely reduced to allow what is the decoupling. So from one side, the economical development that will be decoupled from the environmental impact. For doing that, we need to find alternatives. So that's why we focus. We have a big project where we are working together with several universities, with Dresden University, so RWTH, Aachen, and Dresden University. And we are several professors with different expertise, and we are responsible together with Professor Günther from Dresden University to analyze which are the best scenario in terms of materials, but also in terms of component. And then at the end, the last phase of this project will be even at building level. So because of course we assess in this case, we compare scenario. That one example is reported in this slide, where we can compare steel reinforced double T-beam with the carbon reinforced carbon fiber reinforced double T-beam. And we also, I mean, as first analysis, we analyzed the materials, so then the component together. And then we will see, actually, the next step, we will be try to understand which shape could make the CO2 emission could make less CO2 emission. Our focus is not only, I mean, I will talk today about mainly the ecological performance, so actually focusing on one of the indicators, that's a carbon footprint. But our analysis is on sustainability performance. So we are taking into account the 3 dimensions of sustainability. When we say the 3 dimensions of sustainability, we mean ecological, economic, and social. And we always use this life cycle thinking approach. That means we are considering the product from extraction of raw materials to manufacturing, use, and the end of life. So that is our approach. And actually, we use this approach, it's our inspiration, our main approach in our work. In this case, we are considering, we are applying it in the carbon fiber. We are, what we talk about applying life cycle thinking approach and sustainability assessment by considering 3 dimensions, we are talking about life cycle sustainability assessment. It was defined the first time in 2008 from Professor Finkbeiner, then was published actually from Professor Klopfer in International Journal LCA in 2009. And until from there on, there were lots of implementation, and the three methodology that are the basis of this integrated application are have reached a different level of development. Life cycle sustainability assessment means apply contemporary to the same functional unit and equivalent system boundary, the 3 social LCA, life cycle assessment, and life cycle costing. Life cycle assessment, that means environmental life cycle assessment, has been already standardized according to the ISO 40040. The life cycle costing has been standardized only for building sector with the ISO 50686, the part 5th, the 5th part. And social LCA actually is going to be standardized by 2024 with the future ISO 40075. I will focus my attention on the environmental one today. So that was the first was standardized. The framework is reported here. So actually we define goal and scope, we have life cycle inventory, we collect the data. Then we have life cycle impact assessment that translate the emissions, so the inventory part, so emission to the impact, so with through a classification and characterization factor. And then there is the interpretation, that is the way where you are analyze parameter, you understand the scenario, you compare different scenario, and you tie your conclusion. So in this specific case, we have with more a comparison. So the goal and scope is clearly defined. We want to compare 2 different walls, and both of them actually are equivalent in terms of function. And we are, but there are different materials. So from the other side, we have a concrete fiber, and the other one is on the conventional one with steel. We define, in this case, not the cradle to cradle, so to grave, as it is, so not the entire life cycle, but in the first analysis, we focus mainly on the cradle to gate, so to the production, until the production of it. Then we have not considered, I mean, the transport has been including 100 kilometers, and it's included mainly because it's in Germany, and all the different, and all the different elements have been considered, at least to understand what I mean, the main component of the wall have been considered. This is what we got. I mean, the focus today is mainly the CO2 equivalent. So we are not showing other environmental impact like acidification potential, eutrophication potential, but that have been analyzed, all of them. But in these few slides, I will show you what is the result. So you see the result focusing on the CO2 equivalent, so the impact on global warming potential. And you see actually that we have a range of different value, because it depends on different parameters, depends on the energy use, electricity mix use, depends on the mix of the carbon fiber itself. We need, in terms of steel, for example, we have a different production with the hydrogen, with renewable energy. So because this is, I would say, it's a summary of more studies. From one side, focusing on carbon fiber, but the other, we are working very close together with ThyssenKrupp, that is important company producer of steel, and they of course work a lot to understand which are their scenario to produce neutral carbon steel. So that's why this cooperation allows us to follow up on the conventional carbon steel, and at the same time with our work with this big project on the carbon fiber. The best performance, which are also the parameter that play a role, another important parameter that play a role is the lifespan. So we are considering carbon fiber reinforced concrete in 100 years. In that case, because it's it's a good lifespan, then in this case we can really get a definitely better performance compared to its similar steel reinforced concrete. So as I said, we have the opportunity to present, so to work also in terms of to compare not only the materials but also the double wall, to identify which are the different parameters, and to understand where actually is the optimization potential for the carbon fiber. What clearly realized that if one side for lifespan, we have a good opportunity to reduce in terms of materials, because it has last longer than steel. We have also another important opportunity, and that is more on the shape. Because what is important for carbon fiber is that you can really reduce the amount of materials that you use to play the same functionality. So that has been not explored yet. We already understand that there is a huge potential, and that will be the next step to work on it. So that's a further example. I won't stay longer, also for a question of time. I want to just maybe one thing to highlight, that of course, if we have opportunity in carbon fiber, from the other side, we know that also steel, as I said, steel also improve. I mean, the producer of steel are also focusing on reducing CO2, become as fast as possible as carbon neutral. And that is clearly when they switch to a production still with the hydrogen, that will be really a really good improvement for their steel production. So even there, we have to really explore further which is the opportunity for the carbon fiber. Okay, so that is mainly my conclusion. So as I said, we have for sure the carbon fiber has a huge CO2 emission in the production of materials itself, but has a potential to reduce the CO2 in a component because we can use less materials, and we have to understand which is the mix that makes that, which are the shapes that they make better the CO2 performance. So we have to analyze this scenario. From the other side, we have steel that still play an important role in the today construction field, and also in that case, the electricity mix and the direction to use hydrogen in the production phase will reduce as much as possible the CO2 also in the conventional concrete. For this, I stop my presentation and I thank you for your attention and happy to answer a question if there are, or to give the floor to my colleague.
Thank you, Professor Traveso. For Q&A, we will be putting the last section, so you can you don't leave, okay?
Sorry, I'm not able to stay. I informed already the organizer because I'm in another conference right now.
Okay, so... okay. How many time do you have now? 5 minutes? Okay, we may put the Q&A here. Anyone has questions?
Yes, and I can answer directly in the email.
Okay, okay. If we have one, okay.
Thank you, thank you.
Oh, unless we can see someone have a question. Who has a question? I think there's a question.
I think they write the question directly in the chat.
Yeah, in the chat.
I can answer to them by chat, so you don't stop the presentation. You can go.
Okay, okay. So, okay, thank you. So now we move to the last talk by Professor Dr. Victor Michelin. Professor Michelin is the director of the Institute for Construction Materials and full professor at the Technical University Dresden, Germany. He is editor of journals Cement and Concrete Composites and Materials and Structures. He is a member of the Science Academy of Saxony and the Russian Engineering Academy. He is Rylam Fellow and awardee of Wasson Medal for Materials Research by American Concrete Institute and the Innovation Award of the Bauma 2016 Munich. Today, Professor Woote Michelin will talk about integrating reinforcements in digital fabrication with concrete. Professor Michelin, it's your time now.
Okay, thank you so much. Can you see my screen?
No, I
Not
can't.
Yet?
Not yet. Okay, right. It's okay. I can see it now.
Okay, excellent. Okay, thank you so much for this kind introduction. Dear colleagues and friends, ladies and gentlemen, welcome to this presentation. I'm Victor Michelin from TU Dresden, Germany, and I'm going to talk about sustainability as well, but this a little bit from different perspective. I will focus on digital fabrication with concrete and in particular on integrating reinforcement in digital technologies. So 3D concrete printers is indeed a very dynamic and rapidly developing field of research, and this for good reasons. First, the new digital fabrication methods offer higher geometrical freedom, quasi the urgent need to increase productivity in construction industry, which indeed has been stagnated over decades already. This tendency is alarming, specifically against the background of worldwide continuously growing demand for new construction in combination with shortage of skilled labor for on-site operative work. Automation and digitization in construction are the only feasible options to master this challenge, which presents the social and economic dimensions of sustainability. Note that tools for digital design and planning are already well developed. Obviously, the seamless data flow from digital planning into fully automated construction would mark the qualitatively new technology level, which is often referred to as construction industry 4.0. In this graph. This material concept was recently successfully used by our partners Shinsu Corporation for fabrication of integrated formwork for bridge supports. Another option is to place reinforcement prior to concrete shaping. In these two cases, reinforcement is enhanced with concrete in an additive process, while it doesn't provide any substantial support for fresh concrete. In contrast, in these two examples, reinforcement provides support to concrete. Here, the concrete shaping process is a formative one, since the shape of the element is defined by the supporting reinforcement. Obviously, we have here two fabrication steps, first reinforcement and then placing concrete. It works also other way around. Reinforcement can be placed on of reinforcement between layers of concrete. It is a contiguous process, even if we place concrete directly after placing reinforcement, as is shown here on the right side. So you see a little video also for this. Cross-layer encasement is also a contiguous process. Vertical or inclined fragments of reinforcement, as well as the attendant horizontal components, are placed before the next concrete layer is deposited. The concrete layer encases the fragments, but still doesn't cover their tops, since further reinforcement fragments will be attached here in order to establish cross-layered reinforcement. The third approach also addresses cross-layer arrangement of reinforcement. However, the key feature here is the reinforcement is induced by penetration while the concrete is still in its fresh or plastic state. Typically, straight one-dimensional pieces of reinforcement are used for this purpose, either pins or screws. Also, this process is a contiguous one. In contrast, the fourth single-step approach is a simultaneous process. The reinforcement is entrained here into concrete bulk before material deposition. For extrusion-based processes, entrainment of cables or yarns can be realized as a part of the printhead process. Short fiber or textile or fine meshes can also be entrained. Well, following this sequence of examples, you probably got already the feeling how the suggested classification framework for integrating reinforcement in digital fabrication processes looks like. Indeed, it considers the sequence of distinct processes according to manufacturing timeline of the product as a starting point. It begins right here where the RILEM framework for digital fabrication is concrete ends. It means at the level of the process subclass for shaping concrete, either additively or formatively. For additive manufacturing methods with concrete, reinforcement can be integrated within a single process, as shown here in the middle. However, the integration of reinforcement prior or after concrete shaping, it means as a separate step, can be performed both with additive and formative concrete processes in a similar manner. These options are indicated in the classification as two-step processes. Additionally, concrete mixing is defined as a prep process preceding any concrete shaping process. During mixing, short fiber may be added as dispersed reinforcement to produce either already ready mix or dry mix for further use in both single-step or two-step digital processes. Here we are talking about the key features or categories. You see also that every example as I provided are assigned for one of these categories. And finally, the classification also provides the link to structural design issues by naming corresponding options for the choice of reinforcement, such as cages, meshes, bars, cables, or short fibers. So you find more information on this in this article I cited here. So finally, I want to follow up the talk by my colleague, Professor Traverso from Aachen, and show you some applications or some new development in textile reinforced concrete. You see here some examples, which I will not address in detail. And what is new in our approach is that we use carbon fiber, but not impregnated by some polymer resin, but rather by mineral materials, which improve the sustainability considerably. So you see here some essential steps of coating or impregnating the fiber with this mineral suspension. And what we get as a result are either uniaxial bars, like shown here. So we use micro cement materials or geomet polymer materials for coating or for impregnating, and also the small unit which can be used already on a kind of industrial scale for producing bars. Here we impregnate several yarns and then bring them together, and you see also that we provide some additional here wrapping for this bars to improve their performance even better. So we can go further and produce two-dimensional elements such as meshes, so which is typical for the use in concrete industry today. So this is one of the examples of how it looks like, but we can go also out of plane and produce some reinforcement for shells and other complex structures, as shown here, of course, using some robot tools for that. So again, we see here a product of such development. And we can apply in the second step, for example, 3D printing to provide concrete layer on top of this. So the next example is production of three-dimensional reinforcement structure, again, based on the use of robots. In this case, we provide the yarn from this point, as shown here. And this is the frame which rotates around this point. At the end of the day, we get here the structure for a balcony, little balcony, which is much lighter than corresponding reinforcement made of steel. You see here's a more than factor of 10. Having the same load can printing process, putting it between the layers as shown in this example, or introducing it directly into the concrete filament and depositing it directly with the concrete filament as shown here in this example. And basically this is all for today. Thank you so much for listening, and I'm looking forward to your questions.
Okay, thank you. Thank you, Professor Michelin. I think it's a time to have a question. Is there anyone have a question? We can raise your all of you can raise your hand if you have a question. Yeah, Yang. Yeah, you can speak now, Yang.
Okay. Hello, Professor Michelin. You introduced a lot of the integrating methods about the digital concrete construction. I have a question as to the reinforced in digital concrete fabrication. What is the efficacy of the integrating methods?
So you ask about the efficiency, right?
Yeah. Yeah.
Well, this is what we need to figure out, right? It depends really on the context. I mean, you cannot kind of say that one of this concept of integrating reinforcement works in all the cases in the same way, and so this has the same efficiency. So it's no way to offer something like this. But rather we can, for example, consider that we go for steel reinforced concrete. And in this case, of course, we are limited concerning the flexibility of the process due to rigidity, for example, of reinforcement. And in this case, well, following a little bit different path can be a best case in comparison to what I showed at the very end, where we have very high flexibility using these yarns, which can be really brought in any possible shape. And actually it can kind of wet in wet process, right? So we have still very flexible yarns. We can put it into fresh concrete. We have also benefits with respect to the bond, etc. So this is the first. I mean, even from the theory, we cannot claim that one method is perfect and other methods has no use. But the key is actually the proof from the practical applications. And only when we go into practical application, we really know the value of all these approaches, right? Because as very nicely presented by a colleague from Munich in the very first speech today in the plenary, there are few phenomena which occur in the praxis which we are not able to consider just drawing the concept as researchers. Okay, I hope it answers your questions to some extent.
Okay, thank you.
Professor Huang may have a question. Professor Huang.
Hello, Professor. Can you hear me?
Yeah, I can hear. Good to see you.
Nice to meet you again. Hope you can visit Zhejiang later.
Okay.
Do you have any plan? Is this okay? Everything okay in Germany, in Dresden?
Absolutely, absolutely, absolutely. Yeah, sure. So you're welcome to come and to visit us.
Okay, thank you. I don't have any questions.
Okay, excellent, excellent. Yeah. I believe there are some questions to Professor Shi.
Well, anyone have any question? Who? Can I see Lu? Yes, Lu, do you have a question? I have personally, I have a question for sorry. Any problem? Professor Michelin, I have a question. Because I think your video, you just say, I can say a lot of examples in your videos. It's impressive. So my question is, how far away those technologies from lab to practice uses? And what is the challenge?
Yeah. I believe it's really the matter of kind of engagement of the companies, right? If the companies want these technologies, if they are kind of ready to accept this technology, they can bring them to practical use, I believe, soon enough. This is what we see with different 3D printing technologies which are used. So the companies are learning very fast, and then they can also, of course, express their wishes to us, to researchers, to contribute to this and that improvements. But you know from your own work for sure that we as researchers have some limits, of course, right? We cannot upscale. We cannot really bring it to perfection from the kind of use this for mass production or whatever, right? So on the lab scale, you are very limited in this. But for example, if you refer, for example, for last couple of videos, I showed you this handling of this carbon reinforcement. So we are, as a research institution, are ready to deliver this base to the industry to start to implement this. So it's ready for implementation actually. But we cannot go for implementation ourselves, so it's not our business, right?
Okay, I understand. Okay.
And of course, what we cannot judge as researchers, at least it's not in my capacity, how interesting is this for particular companies from financial point of view, from whatever else point of view. This is the companies needs to decide for themselves, right?
Yeah, sure. I agree with you. So we will move to next question. Lan, you have question, Lan? Okay. Yes, you can speak now, Lan. Yes, you can speak now.
I have a question want to ask Dr. Ran. The first one is, as we know, concrete often serves with steel reinforcement, and the alkaline environment in concrete can neutrally protect the steel bars against corrosion. For carbonation occurs to concrete, of course, the alkalinity will decrease. or concrete will be neutralized, but the steel bars will face high risk of corrosion. So how could we get a balance between carbon sink and engineering performance for concrete?
Yes, thanks for your question. I think this is a very important question, and a lot of researchers try to address this issue, but currently I don't see many good answers. In Canada, for example, the carbon Q, when concrete reacts with carbon dioxide, and the calcite will be formed, or calcium carbonate. So they try to regard the reaction between carbon dioxide and the concrete as the addition of the calcite. They just say, oh, we add some additives, that is the calcite. And actually, recently in McGill University, and they also have some research regarding the accelerate the carbonation. They try this is not the natural carbonation. They try to use a very high, high concentration of CO2, and they reported that they will form a very dense layer on the surface layer of the concrete, and they say, oh, this dense layer may inhibit or may prevent the chloride penetration into the deeper section of concrete. But this is still within the lab, and the practical trial or some demonstration is still not there. It's still absent. So we try to do this research in the future. Thanks for your question. Yes.
Okay, thank you for your reply. And I have the second question. When regarding carbon neutrality, increasing the recycling ratio and rate may be another way to save materials, energy, as well as reduce carbon emissions. What do you think we should do in the issue of recycling for sustainable engineering materials?
Sustainable engineering materials. Actually, when I was in UK, I was involved in Horizon 2020 project, and actually, we just damaged a building in Portugal, and then we recycled all the materials. Then finally, we built a new structure, with these engineering materials. Ranging from the glass, from the ceramic, from the steel. So a lot of engineering materials can be recycled, but actually, it may, cost, it may be costly, and some extra energy may be needed. And I think, there's a professor, he's just now, she's working on the life cycle assessment. I think a comparative or systematical life cycle assessment is really needed, and to assess whether the recycling of these engineering materials are sustainable, or are they really worth it? I think this is an issue. Another thing is, there are also a lot of materials, like some wastes. Actually, now, in China, we still try to recycle them, but actually, it is not easy. And because a lot of engineering materials, their activity is so low, we try to activate them. And during this process, some chemicals, some, other extra processes like grinding or chemical activation or heating are needed. But if we use these procedures, or if we use these materials, their sustainability is in doubt, So I don't think all the engineering materials should be recycled. It depends, and there should be a balance between the landfilling of these engineering materials, or the recycling of these materials. So there should be a balance. Okay, hopefully this can answer your question.
Okay, thank you.
Yeah.
So thank you, Dr. Luan. Professor Michelin, do you have a question?
Yeah, thank you. Actually, I also have a question to Professor Ran. Talking about carbon cure, I understand you have your own experience with this technology. So what is your experience with respect to how much carbon dioxide we can really bind here? And what is your expectation to the further development? So I mean, it's not about just the fact that some carbon dioxide is bound, but how much. And so we are talking about a process where concrete is still fresh, right? So it's still in a fresh state. So how much can we achieve?
Okay, Professor Victor, yeah, thanks for your question. Actually, last year we just successfully secured a grant from the Zhejiang province, and we collaborated with a very big company in Zhejiang province. And actually, in my friend in Singapore, they also had launched the same manufacturing line of the carbon cube, and they find only 1% of carbon dioxide can be sequestrated into the concrete. So this is not enough. And in here, we try to develop some new chemicals. This may help the carbon dioxide permanently stable, or accelerate the carbonation reaction between the carbon dioxide and the concrete. Yeah, this is the one way. Another is we try to develop some new equipment. We try to use we all know sometimes the reaction between the concrete and the carbon dioxide may not be very fast, and we try to there should be what should I explain? There should be maybe recycle this concrete carbon dioxide. First there will be some carbon dioxide emission during the first reaction. Then some dioxide will be injected into the second reaction tank, and to further increase the capture ratio by the concrete. This. So yeah, that's all.
So thank you, Dr. An. So it's I have a personal question. It's that when you saying because you introduce a lot of work by your group or your colleagues, I think it's not an easy work to just put one thing. For example, just put land together. So what do you think about establishing links between different technologies or different techniques to have one goal, for example, for reducing CO2 emissions? So in your opinion, you have introduced 4 directions. So do you have a plan to make land together to reduce carbon?
Thanks, Professor. And I think it is a very good question. And actually, a lot of research areas in concrete, we also can call this, the low carbon process. For example, if we use some, chemical additives, it can increase some performance of concrete. So in another word, that is, it may, increase the surface life, and that it can save the materials. And this can also called the low carbon process. Another way, the reasonable mix design, you can also save materials. So it can also call this process a low carbon process. So the low carbon concrete, so I think, the categories can be varied, and a lot of attempts can also be called the low carbon process. So, and actually it is very difficult to, combine all these, components like the low carbon binders, low carbon aggregates, added mixtures or reinforcements into one goal, the carbon neutrality. So I think it is quite difficult. And the problem is, I think, the low carbon, we call it the carbon neutrality, durability, or the strength. Can we have all these three at the same time? I think this is the challenge. Sometimes if we want to make the concrete low carbon, it's very easy. We can use a lot of in SCMs, like the fly ash or slags. We can, of course, we can reduce the carbon footprint, but sometimes the durability, for example, the shrinkage will be, serious. So this is not, economical or feasible. Another thing is, sometimes we can durability, the performance of such as the strength are in doubt. So we don't think this is a right way. And now there's still a gap between the material scientists and the structural scientists and engineer. The material scientists, they focus more on the material scale, and they don't have a strong background on the structural engineering. The structural engineers, they do have any knowledge regarding the materials, especially in a lot of scales like the micro scales or the meso scales knowledge. So there's still a gap between the scientists and the engineers. So it is still, we still have a long way to go to reduce carbon footprint, and while maintaining the high performance of concrete. Okay.
okay, Dr. Wang, thank you for your replying. So you go very far away from what we talk about, I think. That's good. Okay, due to the time limit, we couldn't address all questions. So thank you all of you. Thank you, Professor. Thank you, Liu. Thank you, all audience. Okay, I think we can this session just be here. Okay, we can close this one. Okay. If you have any other questions, we just can talk by email or other ways.
Recording.
So, hello everybody and welcome to this session of funding opportunities. My name is Kai-Uwe Schröder. I'm head of the Institute of Structure Analysis and Lightweight Design of RWTH Aachen, and it's my pleasure to moderate this session. Intention is nothing unless you do it. This is something what the famous German poet Johann Wolfgang Goethe said. And from that point of view, I think this is maybe the most important session today, because it's about how to get the money. And from this point of view, it's my pleasure to announce as the first speaker, Dr. Katja Young. Dr. Katja Young is head of the Division Asia within the department sponsorship and network of the Alexander von Humboldt Foundation. Her responsibilities include managing the Theodor Lünen Research Fellowship Program, as well as the promotion of the Humboldt Network in Asia. She studied sinology, philosophy, and business administration at the University of Würzburg in Germany, Beijing Language and Culture University, and Peking University. She earned her PhD in sinology at the University of Würzburg in a research project on contemporary urban China, sponsored by the Federal Ministry of Education and Research of Germany. Afterwards, she acted as managing director of the Confucius Institute at the University of Bonn since August 2017, before joining the Alexander von Humboldt Foundation in March 2021. So please, Ms. Young, the stage is yours.
Thank you very much. And I would like to share my screen with you. So please tell me if you can see my screen.
Fine, but we do not see the presentation mode.
Okay, yeah. Better now?
Fine.
Wonderful. So, hello everybody. I'm very happy to introduce you to the Alexander von Humboldt Foundation's funding opportunities. And as you just said, my name is Katja Young. So the Humboldt Foundation basically offers sponsorship for outstanding international scientists to help them to come to Germany and conduct research in Germany. And thus we hope to strengthen the research location Germany, and also to strengthening cutting edge research through internationalization. As you can see, our main funding bodies are the Federal Foreign Office and the Federal Ministry of Education and Research in Germany. And our budget for this year, our annual budget is about 150 million euros, which translates to about 8.2 billion renminbi. So what do we do with this money? We fund international top-tier researchers, also some Germans actually, but going to talk about the internationals today, obviously. And what's remarkable about us is that our sole selection criterion is academic excellence. We do have no quota whatsoever for gender, for countries, for disciplines. So whatever your research interest is, if we believe that you are an outstanding scholar, we would like to happily fund you. And we believe in the sponsorship of people, not projects. Thus, we do not just sponsor you for one project, but we would like to sponsor you for your entire academic life. So you have the free choice to choose whichever research topic you're interested in. And also you need to find an academic host in Germany. I'm going to talk about this a little bit more in detail in a minute. And also this academic host you can freely choose. What's also interesting about us, as I said, is that we would like to sponsor you, or we offer funding opportunities a lifelong or an academic lifelong, and therefore we create a network. At the moment, currently, there are more than 30,000 Humboldtians, actually including 57 Nobel Prize winners, which we are very proud of, in over 140 countries. And as we say, once a Humboldtian, always a Humboldtian. So in a nutshell, it's quite competitive to get our funding. But once you got it. We offer a range of alumni sponsorship opportunities, which are then very easily accessible for you. You can easily come back for renewed research days to Germany. You may apply for research group linkage program to link you to German researchers. You may invite German scholars over to you to visit you in China, and so on. There's a variety of programs. So this is also interesting about us, I think. And we do actually offer a variety of research fellowship programs, but the one I would like to talk to you today, because I think that's the one you are probably most suited for, is our Homeworld Research Fellowship, which is targeted at either postdoctoral researchers or experienced researchers, depending on how long your doctorate has been completed. You may apply for the either or another. So within 4 years upon completion of your doctorate, you could apply as a postdoctoral researcher, which means that you could stay in Germany for up to 2 years. Or if your doctorate was completed between 4 and 12 years ago, you could apply as an experienced researcher and come for 6 to 18 months to Germany. And also accordingly, our scholarship amount would vary, but in both cases there would be additional benefits, for example, for children or for spouses that you may want to bring along. So if you want to apply, of course, you need an above average doctorate, you need to send your academic publications and so on. I think basically what you need to send to everyone if you apply for scholarship. The two things that I would like to talk about a bit more is that you need an academic host. So you need to find a scientist who's based in Germany and who is willing to provide you with the facilities to do your research. And this could basically be anyone who's working at a German university or research institute, who is also willing to collaborate with you. So first of all, once you have your project, you need to find a German host, a German fellow scientist who would like to host you. And after he agreed to do that, you basically apply for our funding together. So this is very important, and I say a bit more on how to find this host in a minute. And the other thing that I would like to point out, because people often ask that if they when they consider coming to Germany, is the language skills that they need. So basically, if you apply for scholarship in the social sciences or in the humanities, we would expect you to speak some basic German. For the natural sciences, however, this is not necessary. We would still welcome and suggest that you learn some German, and we in fact offer you to study German. We offer some free German courses for you, but you usually do not need it at the institutes, because the research institutes are usually very international and speak English as a working language anyway. So as I said, it's very important to find a host in Germany, and therefore you might want to look at our own homepage, where you can find hosts. There's also the Euraxis Germany website. It's also here on my PowerPoint slide, or the German Research Institutions portal Gerrit, where you can easily find scientists in Germany. But maybe you also know someone from past collaborations or from the literature and so on. So once you found one, you're very welcome to reach out for us. This is our contact information, and yeah, would be very happy to welcome you in Germany as a Alexander von Humboldt Fellow. Thank you.
Yes, thank you so much, Frau Janke, for this nice presentation and perfect match to the time schedule. Due to the tight schedule, we are not open for questions. So if you have any questions, please contact the speaker directly. And I will continue to the second speaker. This is Susanna Otten. Susanna Otten studied German philology and history at the Leibniz University in Hanover. And from 1989 until 1993, she worked as a German language lecturer at various Chinese universities. She continued her teaching career at the University for the Humanities in Ulaanbaatar, Mongolia. And from 2001 till 2005, she worked for the German Academic Exchange Service at the German Embassy in Beijing. After returning from China to Germany, she held various positions at the DAAD headquarters in Bonn, and this was only interrupted by 2 years as the German vice director for the Chinese-German Graduate School at Tongji University in Shanghai. And currently, she is the head of the Department for Transnational Education Projects in Europe, Asia, and Central Asia. Please, Ms. Otten, the stage is yours.
Thank you very much, Professor Schröder. I try to share my screen. Can everyone see that?
Yes, but not the presentation mode.
Yeah, I see. It's better now? No, it's not better. Sorry, I have some problems. It's better now?
Unfortunately not. I think the problem is the reference view, also diese Referendarenansicht. If you would switch off it, please, then it would be better, I think.
I have no idea what you are talking about. Okay, someone is supporting me. Thank you very much.
Now it works.
Thank you. Okay, thank you, Professor Schröder, honorable guests and participants. Thank you very much for the opportunity to present the funding opportunities of the German Academic Exchange Service at the second Sino-German Sustainable Development Forum. The German Academic Exchange Service, or the DAAD, as we call it in German, has a large variety of different funding programs. We differentiate between programs for individuals and cooperation programs between German and Chinese universities. Can you please give me the second slide? Thank you. I would like to start with our programs for individuals. We offer scholarships. To start with it, we offer scholarships for university summer courses in Germany for Chinese students and graduates. With their stay in Germany, they can improve their knowledge of the German language and of the German society and culture in general. For graduate students, for PhD students and scientists, we offer short-term scholarships up to 6 months for studying and research at a German university. Chinese professors with an invitation of a professor of a German university can also obtain a research scholarship. We have then a special program, a joint scholarship program with the Chinese Academy of Science. Chinese PhD candidates can get a support up to 22 months for a research stay at a German university. This program is only for the CAS University and for PhD students from CAS research institutes. We also work together with the CSC, the China Scholarship Council. We offer for outstanding graduates from Chinese university and institutes a scholarship from 6 up to 24 months. The objective is to intensify German-Chinese research cooperation. This is a program for postdocs. Last but not least, we offer study scholarships for Chinese students in the field of the performing arts, in architecture, music and fine art, design, visual communication and film. If there are any questions about the different scholarships we offer, our head office in Beijing provides an advisory service and can help. We also have information centers and points in Shanghai and in Guangzhou. Thank you for the third slide. As I mentioned before, besides the individual scholarships, there are also programs to support the cooperation between German and Chinese universities, for example, in the field of transnational education. The Transnational Education Program is a worldwide program. Transnational Education, TNE, refers to university, degree courses, and individual study modules which are offered at the Chinese host university, essentially for students from this university or the region, under the main academic responsibility of a German university. With this program, the German and Chinese partner can set up a study program, establish a joint institute at the Chinese university or an interdisciplinary global center, or even establish a German university in China, which hasn't been done until now. Nowadays, this program will mostly include courses for Chinese and German students. In the past, there were only projects for Chinese students. The application for this program has to be sent in by the German partner. The program is open for all fields of study, so all kinds of environmental projects can be supported. TNE projects are established on a long-term basis. The funding could last up to 8 years. Funding includes costs for academic and administrative staff, costs for flying faculty, cost for research, exchange of scientists, and so on. Projects will be selected on a yearly basis, not by the DAAD, but by a panel of German professors. Another important and well-established program between German and Chinese universities is the Integrated International Degree Program with double degree. The goal of this funding programs is to develop and implement international degree programs with curricula jointly offered by a German and a Chinese university, to enable highly qualified German and Chinese students to alternately study at the German and Chinese university and obtain 2 national degrees, either as 1 degree jointly conferred by both partner university or as a double degree conferred by each partner university. Funding for this program is granted for 4 years, but can be extended when the program is established successfully. The program is also open for all fields of study and will be selected yearly by a panel of German professors. The third and last program I would like to mention is a program especially for University of Applied Sciences, a university type which is very interesting for and a discussion in China. Universities of Applied Sciences, UAS, educate students to become highly qualified professionals for the market. In this function, the universities fundamentally contribute to the economic success of numerous companies in their respective regions. The UIS international program enables University of Applied Sciences to prepare students more optimally for the globalized labor market and to provide them qualifications as professionals for industry in cooperation with their business partners. At the same time, the program aims to strategically anchor and sustainably implement the internationalization process at all universities levels and across all member groups, as for example, students, instructors, researchers, and administrative staff. The DAAD offers 4 different modules in this program, which can be used individually or in combination. Module A, projects is a preparation module for preparation purposes. Module B is the implementation of the projects between Chinese and German universities. Module C is the scholarship part for individuals for study visits abroad to China or to Germany for both sides. And module D is consultation, continuing education, and exchange of expertise. Funding in this program will last between 2 and 4 years, depending on the different modules. The maximum funding for a project is about 400,000 euro. This is the last program I would like to mention. There are many more. If you have any questions, you can contact us. Thank you for your attention.
Yes, thanks, Ms. Otte, for this lot of information. And again, please contact her directly if you have any questions. So we will continue, and it's my pleasure to introduce now Mr. Haldor Berg. Haldor Berg is the Senior Country Representative of EURACCESS China, an initiative of the European Commission. And Haldor worked with the project for 8 years, and during that time, he helped with creating a network of over 6,000 researchers based in China, and helped with building several different networks of researchers, innovators, and academics in China. With a master's degree in international relations from Zhejiang University and a postgraduate diploma in the same field from the University of Iceland, Haldor worked previously for the Foreign Service of his home country, Iceland. Working in the Icelandic embassies in Beijing, Brussels, and Copenhagen, he built expertise in European-China relations and science and technology diplomacy. So please, Mr. Haldor, start your presentation.
Thank you, Mr. Schröder. You can see my presentation. It's visible. Fantastic. All right, it's a great honor to be here with all of you today. Thank you so much for inviting the Icelander to this Sino-German forum. I guess what I bring to the table is the European dimension, let's say. Earlier, Katja from the Humboldt was talking about the EURACCESS in Germany. So EURACCESS is this network of centers that are run by the member states of the European Union and the associated countries to the European Research Area. And they're there to facilitate mobility. For example, by introducing mobility funding, other funding, give other services like that. Admittedly, EURACCESS China is a little bit different from all of that. I belong to another part of EURACCESS that is called EURACCESS Worldwide. And what we do is we sort of try to build networks of researchers between China and Europe. We have offices all over the world, including in Brazil, in Washington, India, Japan, etc. And we've been here in Beijing since 2009. So the project has been around for a while, and I'm right now sitting in our office in Beijing. So if any of our Chinese colleagues are in Beijing at the moment, I would be happy to invite you for tea or coffee at some point. Always welcome. So the two main sort of groups that we work with here are, on the one hand, the European researchers that are coming here to China to work. We work, for example, a lot with the German scientists that are here in China and try our best to support that community. But we also work with the Chinese researchers that are interested in connecting with Europe and the European research area. And the way that we do that is that we do it by information sharing, by creating networks, holding all kinds of events, and doing webinars and so on. So we do like really regular events. We are on the ground in Shanghai, Guangzhou, here in Beijing, doing networking events and creating a community of researchers and all the kind of different thematic networks, etc. But one of the big things that we can help you with is to sort of introduce to you the funding opportunities available in the European research area. So the European research area includes all the member states. So if you're interested in German funding, for example, that's also European research area funding. And we have a lot of experience introducing people to options like the DAAD, the Humboldt, and so on. Of course, there are also great German offices here in Beijing that you can go to as well. And I'll be happy to introduce you or in any way, always happy to help. So these are the things that we can do. But on top of that, what we can also sort of introduce to you is the European dimension. A lot of those big projects in sustainability, when it comes to sustainable development and environment, etc., requires great effort. And it's clear that we need to include as many stakeholders as possible. So a lot of these research projects are almost by their nature really big. Includes organization for a lot of different countries. So in Europe, we have something called Horizon Europe, previously known as Horizon 2020, which is the research and innovation framework program, which is there to sort of support pan-European research collaboration. So let's say that you are working with Germany, but now you want to expand it and start working with more European countries, including Germany, go through this cross-European thing. Horizon Europe has a lot of different options. And I'm going to introduce a little bit how this works if you're from the point of view of somebody standing here in China. First of all, if you're an individual researcher, there are funding opportunities available in Horizon Europe that you can just right now apply to and is open to you immediately. For example, the European Research Council is very, very prestigious research funding that gives you funding for several million euros over a few years' time to do sort of independent research and build up a team in a host institution anywhere in Europe. This is open to all Chinese researchers, and many of them have come to Europe doing exactly this. There's also the Mary Skłodowska-Curie Actions. We have hundreds of Chinese researchers that have done fellowships, postdoctoral fellowships in Europe using this option, including in Germany. And we do regular webinars and introduction meetings trying to train people and help them to learn how to do this. So if you're interested, you can just join our network, and we offer all these services to you for free. Maybe of a lot of interest in my experience to the Chinese institutions are sort of like the bigger projects, the global challenges, the ones that fall under the pillar inside Horizon Europe called global challenges. And clearly the big one is, for example, climate change. That's one of the big things that Europe is trying to tackle right now, with Germany driving a lot of the movements there. So how do you participate as a Chinese institution? Well, the good news is that all calls within this pillar, Horizon Europe, are in principle open to anybody anywhere in the world. There's like a tiny sliver of calls that are only open to European actors, but it's like less than 1%, if I remember correctly. Most of them, almost all of them, are open to everybody. So we're always happy to include excellent institutions from elsewhere in a European consortium. And then you can like participate in the research and so on. The problem is that in those cases, the funding to do the research outside of Europe needs to come from yourself. You need to see the benefit in joining these programs and fund yourself. Well, there has been this program here in China to allow research institutions to participate through something called a co-funding mechanism. This still exists. This was established in Horizon 2020. So Chinese institutions are able to apply to the Ministry of Science and Technology here in China to do exactly that. And a lot of that happens under the sort of the joint framework that we have for collaboration that is currently being negotiated. But one of the two things that I can tell you about that right now is that we already in Horizon Europe have 2 flagship initiatives that are targeting Chinese participation. And it so happens that both of them are very relevant to the topic of this forum. Number one, we have a flagship initiative of food, agriculture, and biotechnologies. And this is a continuation of a previous project that was really successful in Horizon 2020, included a lot of Chinese institutions, and they are just like continuing that on that trajectory. And then recently it was announced that we also have underway a new flagship initiative on climate change and biodiversity. So if you are interested in joining something like that, in 2022, later this year, they're going to be opening up the calls in that. And like, you know, now this is going to be targeting Chinese participation. So like this is a great opportunity to get involved in European research projects. So that is basically what I can tell you in 8 minutes. I see that I have 30 more seconds. So what I want to say, one thing that's really important here. These projects that we were just discussing are big organizational projects. So the first thing you need to do is to find partners in Europe to work with. That is the first step. So if you have somebody in Germany that you work with a lot, etc., you should, and you know about a Horizon Europe call that you think you would be really valuable in, you should maybe go to them and say, what are you guys up to? Are you establishing consortium? Can I get involved? This is a practical tip to take the first step as a Chinese organization. And that is my time. Thank you so much for having me here today. If you guys could please send me any questions or anything just in the chat box, that would be fine. Thank you.
Yeah, thank you so much, Mr. Berg. And I'm quite happy that I saw at least one ice beard in your presentation. Okay, next speaker, it's my pleasure to welcome Mr. Sebastian Granderade. And one moment, Mr. Granderade is the German co-director for research funding of the Sino-German Center for Research Promotion and the research funding institution established by the Deutsche Forschungsgemeinschaft and the National Natural Science Foundation of China in Beijing. He holds a PhD in developmental neurobiology of the University of Münster, and after appointment as an editor in medicine and life sciences with academic publisher Springer and managing director of an international graduate program at the University of Cologne, he joined DFG's Research Careers Division in 2005. From 2009 up to 2021, he coordinated DFG's International Research Training Group's funding program. And in May 2021, he took over his current position at the SGC. So, Mr. Granderade, please.
Yes, thank you, Professor Schröder, for the kind introduction. Hello to everyone. I'm glad and honored to be here and to present the funding opportunities that are supported by the DFG. I should probably share my screen, and that's what I will do. So, as already mentioned, I'm co-director for funding of the Sino-German Center for Research Promotion, and that is actually a joint venture of the German Research Foundation, DFG, and the National Natural Science Foundation of China. I want to very quickly present the funding opportunities that we offer, but I'll also highlight a second funding opportunity that is operated by DFG and NSFC. Yes, as a quick reminder who the DFG actually is, we are a large public funding organization for basic research in Germany. We serve all branches of science and the humanities, and an important part of our mission is the support of international cooperation in research. Our partner in China is, as I mentioned, the NSFC. This cooperation dates back more than almost 35 years now, was established in 1988. And it extends to the fields of natural sciences, engineering, life sciences, and management sciences. As I said, we have two modes of cooperation for funding such activities. One is the Sino-German Center for Research Promotion, and the second are the so-called joint DFG calls. So let's take a look at the SGC. The SGC was founded as a joint venture of the NSFC and DFG already in the year 2000. As a joint and independent funding institution, and that is indeed a very unique model, and it has proven quite successful. The SGC is an independent institution under Chinese law. Our current budget amounts to approximately 120 million yuan, or 16.6 million euros this year, and this budget is provided jointly by NSFC and DFG. Our tasks are seed funding for long-term German-Chinese cooperations in fundamental research, where we place special emphasis on supporting early career researchers. And the second task, of course, the promotion of bilateral research collaboration and providing advice and information to German and Chinese researchers. Now, we have developed a quite elaborate funding portfolio of different programs. I don't have the time to go through all of this in detail. What I want to point out with this slide is that when we support initiation, we do that by a variety of programs, which range from short-term funding of approximately 1 week to long-term funding up to 3 years. And also, our programs are open and support scientists in the early stage of their careers as PhD students up to the senior level. And as you can see, the eligibility for applications to the center is really focused but not exclusive to early career researchers. All the programs that we offer are applied for jointly with a single application to the center. They are reviewed through the center by peer review and decided within the center. So it's a one application process for both sides. The different programs range from preparatory visits to start the very first steps of cooperation to get to know each other better, through summer schools for junior researchers, workshops and junior scientist forums, up to the 3-year mobility program, which supports international research cooperations for a period of 3 years with a budget of a maximum of 1.5 million yuan, or approximately 220,000 euros. So if you have more questions on the different funding opportunities that the center provides, please contact us. You will find the website at the end of this presentation, or simply by email directly to me. The second line of cooperation that DFG and NSFC operate are the so-called joint calls. These are calls in defined scientific fields which are published almost annually. And here we do not support the initiation or intensification of cooperation, but really full-fledged joint research projects for a period of 3 years. The applications are submitted to DFG and NSFC in parallel in existing funding programs. They are reviewed in parallel, and the funding is provided in parallel from the NSFC and the DFG, but the decision, again, is taken jointly. So the risk of double jeopardy is minimized. The joint calls have been established in 2017, and as you can see, we have a certain drop in the number of proposals that could be funded. That is largely due to the pandemic. It has nothing to do with the available funds for the program. But what we see by the number of applications is that there is a great interest in both scientific communities in China and in Germany for joint projects. And we see pretty continuous demand. And I should close by going back very quickly to the center. You've seen we have a small number of joint call projects funded so far. In the center, in the 22 years of its existence, we have so far funded more than 1,000 projects and supported more than 40,000 researchers by funding this. With this, I come to an end. I thank you for your attention. And if you need any further information, please do not hesitate to contact us either at the SGC or at the DFG. Thank you. And yeah, have a good day.
Yes, thanks, Mr. Granderade, and thanks to all presenters for this valuable information. And thanks to all the participants of the session. That was it. I hope that each of you found at least one way to get funding and to realize his ideas in the future. Thank you so much to all participants, and see you all. Bye.
Goodbye, and thank you for the moderation.
Thank you. Goodbye.
Bye.
So, hello, welcome back, everybody. You've had a wonderful and hopefully also very exciting afternoon. I welcome you to the last but not the least final session of today's forum. I'm very excited to have you here, and I promise it is worth staying. If you've not used the 2 minutes we had of music, go and grab a cup of coffee. My name is Ruth Szymanowski from the DAAD in Beijing, and I will be moderating the following 45 minutes. We have exciting guests from the professor from the Zhejiang University to give us a wrap-up of the parallel sessions of this afternoon. And we also invited 3 distinguished representatives from the industry. So what I will do now, I will try to hurry up and give an introduction to all of them. And then we will go immediately into the statements, because I think it's really worthwhile. So let me please introduce to you the first guest on this roundtable panel, which is Christian Zama. Not only is he a good friend of mine, but he is actually what we call in Germany, Mr. China. You've been here for over 20 years. You are also not only Mr. China, you are Mr. German Center. You are a lawyer, and you started your career here in one of the first German law firms in Shanghai. And then actually what you may most known of, at least to us here in Beijing, you started the German Center in Beijing. Then you ran off to Shanghai and actually built your own German Center there in Shanghai. And you have been successfully not only expanding your work in Shanghai, but also in bordering Taicang. So Christian, I'm really happy. I know you're really, really busy now that Shanghai is opening up. I'm very happy you're here, and you'll also be the first one after I introduce the 5 other participants. So thank you very much for being with us. Number 2 is Zhang Shuhao. You are working for a German company, an engineering company, which is Dres and Zama. I asked if you also have a Chinese name for that company, but I understood that you go by Dres and Zama. Your focus area is energy efficiency and sustainability in the building sector. And you have both national and international experience, so you'll be able to share with us best practices, and especially always working on innovative solutions, and which is really good because our universities are just doing that. They're educating talents to help the industry improve. Thank you very much, Zhang Shuhao, for being with us. And you will have the word in a minute after I introduce to you our 3rd guest, Professor Gunnar Grün. You are from the Fraunhofer Institute of Building Physics. I understand that you're often also in Shanghai, but currently I guess you are in Germany. Is that correct? Yes.
Yes,
so
correctly.
Guten Morgen. It
Guten
must
Morgen.
be very early. I really appreciate you got up this early, as also the other German guests. So thank you very much for being with us. You are working for the Fraunhofer Institute of Building Physics, but of course, you also are part of the steering committee for the Urban Eco-Development Project Center at the Shanghai Jiaotong University, one of the most prestigious universities, not as prestigious as Zhejiang. I'm sorry, I'm not going to make that mistake. And your research interest is the comfort of occupants and indoor environment and the energy efficiency of system integrated buildings. So Professor Grün, I'm very happy you're here. I'm looking forward to your statement. I will introduce all of the 6 panelists, although we will start with the industry. So then I go on with Professor Zhao Yuxi. I am very happy that you're also joining us. You are a distinguished professor at the Zhejiang University, the head of the Institute of Structural Engineering, published lots of articles, very high citation. You won the prize for the National Science and Technology Award. And you chaired the parallel session 1, low carbon concrete structures. And I'm very happy that you will give us a little wrap up. So those who could not be in your session, that we understand what were the major takeaways. So thank you very much, Professor Zhao, for being with us. Number 2 from the Zhejiang University is Professor Huang Fung. You also have your research interest at the structural wind engineering and computational wind engineering for high-rise structures and long-span roofs. So I'm very interested to hear your wrap-up of the parallel session 2. It was the building design and construction in respect to climate change. I think that will be very interesting. And last but not least, Professor Meng Tao, I'm very happy that you also from the Zhejiang University Institute for Building Materials, that you will be able to give us a wrap-up from the parallel session 3. Also, you published very many articles with high citations, winners of the Provincial Science and Technology Awards, and also patents, invention patents. And you will wrap up the session on low carbon construction.
So, Ruth, I can't hear you anymore.
Yep, you're muted.
Hello, everyone. Hi.
Seems everybody can't hear Ruth anymore, or is that?
Yes, but Mr. Zhu is speaking now, yeah?
Can you hear us? Can you hear me? Hello,
Yes.
everyone.
Yes.
My name
Yep.
is Paul Meng from Zhejiang University. I would like to thank the organizers for their wonderful meeting and all professors for their excellent presentations. My research area is sustainable engineering materials. Should I go on?
Okay, I think
Moderator.
where the moderator just lost. You know, if I got it right, may I just, without taking over? I mean, I think Ruth might lost connection. Okay, ladies and gentlemen, if I got it right, you know, I understood that basically I should be first. If you all agree, then I would simply start in order not to waste time, you know, and because then it's your time as well, and of course also from the audience. So may I just start hoping that Ruth will apologize that we start simply without her. Hopefully she will listen, and she will be back in a minute. So I would like to start. Thanks very much, of course, for the invitation for this forum. And I should give a very brief picture because I saw now the introduction of the next panelist, and I know I can keep myself very short. As you know, there's no secret, the German-Chinese business relation is very strong, and of course it applies to the building sector as well. However, what we have right now, if we paint the big picture, is first we do have real estate crisis in China to a certain extent. The sales of real estate is down by 30%, and of course this has an effect to the building industry, to the business potential we see in the German industry, and of course also the Chinese industry will see in China. More importantly is, if in any industry, if the industry is going down in the sense that we have a crisis, of course we always have to judge when the crisis will be over. I do believe the crisis will be over. I cannot say soon, but at least it will be over. So the business potential in general definitely is given for both, for the German industry, for the German-Chinese cooperation in the building sector, I'm sure. Second of all is, always if you face a little crisis right now, the question is this reducing the spending for quality? And this is, of course, a very important part if we look to the building industry, because if we look to the existing buildings, there is a lot we can do from the German industry, but of course also in general the industry can do to reduce the emission in that existing buildings. And yes, if we have new buildings, Germany is very strong in planning. We have a lot of first-class architect bureaus here in China, and we have very strong business in all the construction materials. However, what is missing? Germany has more or less no construction company in China anymore, because that is the problem from the licenses. We had former times Zyplin here in China, very strong, but right now, basically, there are no German construction companies. Please correct me if I'm wrong. To summarize, there's a strong business in the building sector between German companies and the construction sites, if I put it that way. But one thing I would like to highlight, and this is the experience I have in the German center, both in Beijing and in Shanghai and in Taizang, is the same. It's very necessary, if you want to reduce the carbon emission and the waste of energy, that we educate the users in the buildings. Let it be an office building like we have, let it be a commercial building, which we are as well. Let it be within apartments, which the German Center Shanghai also has. Let it be in factories. So if the user behavior will not change, it is very hard to reach a super good result in carbon emissions. Because what we have in the German center as well is, in the summer, the air condition will be put on 16 degrees, and if it's too cold, the windows will be open. And same, of course, in the winter, 32 degrees, and if it's too hot, windows will be open. Instead of regulating, in all offices, the aircon. We do have technology to avoid it, and we educate our tenants. But I just want to say, if we talk about the whole China, that is a huge target. I think the Chinese government and officials can do to reduce the carbon emission. So let me summarize. Good potential. German business already quite strong. Yes, we are facing a crisis, but the crisis will be over. And therefore, I'm very much looking forward for the next years where the German-Chinese cooperation will be even stronger in the sector of building industry. Thank you very much for the time and for the short run. Thank you.
Thank you, Christian. Well, stay with us, and we have some more questions for you later. Next, Zhang Shuhao, maybe you can just give us your perspective, maybe not, if we have Christian now from an industry and he actually extended it to a user's perspective, maybe you can give us just what are the challenges facing carbon neutrality in the building sector from your point of view, from the technical point of view. Maybe you can also use the following 5 minutes to give your introductory statement. Thank you very much, Zhang.
Yeah, thank you, Ms. Szymanowski, for the question. Well, I think the most pressing challenge for the building sector is that the sector itself is responsible for a very large portion of the carbon emission worldwide. So if we look at the data, the building sector is responsible for 36% of energy consumption and 39% of carbon emission among all sectors. So that means our sector is a big hog. So we need really a lot of participants in this sector to help us reach our climate goal. If we now look specifically into the Chinese market, we are actually now seeing two major issues that would withhold a little bit our speed towards a carbon neutral future. The first one would be that the Chinese market is still very CapEx driven. This is actually also a little bit related to the answer Mr. Zama just given. The developers or the clients, they usually look very much into the first quality of the initial investment and the initial construction, but not for the operation. Of course, for the cost side also, they usually only look into the initial investment cost, but not looking into the operational cost. So that would be also very bad for the new technologies to the advanced technologies, because we know these technologies usually require a little bit more investment, but of course they also give you better energy efficient in the later operation phases. So if we can really look at the payback time of these technologies, this data might not look that bad. So that was the first point we're seeing. And the second point is that the database of this carbon emissions in China is still not that transparent to the public. So if we compare to the German system, we have in Germany this Ökobau data, which is publicly accessible for all the users, all the public users. So we can actually use that also as an education tool towards non-professionals, also the clients, the stakeholders, which are not really that deep in this industry. They can also look at this data and see in which direction I can go and which material I can choose for a low carbon building. But in China, this is unfortunately not that transparent. We know that the Zhejiang University is developing this CLDC database for China, but right now it is still not transparent for the public. So I would hope that in the future, if this situation could change, I would be glad to see that.
Yes, thank you, Zhang Hao. Indeed, I think that because China is a very large market with a little bit unbalanced developed area, so sometimes what you can do in Shanghai then does not apply for the whole country. Before we move on to the wrap-up sessions, I would like to ask Professor Grün also, maybe because we already mentioned that you work on collaboration projects. So what are the added values of the cooperation projects between industry and academics to promoting the low carbon building sector transformation? So I understood that we cannot see you, but you still hear us, so we can hear you too. So please,
okay,
Professor
great. Yeah,
Grün.
sorry, my video seems to be frozen or not working. Sorry about that. Yeah, I'm sitting here currently at the Solar Decathlon in Germany in Wuppertal, which is one of the large platforms where we show from academia what students think about how we can turn the future buildings into carbon neutral buildings. And so the Solar Decathlon will be here for the next 2 weeks to see amazing ideas about sustainable buildings. So sorry about a bit of background noise, but that's actually one step where we bring academia to practice. Yeah, we really need to show what is possible in building buildings. And this is something we do since decades as Fraunhofer IBP. We work on how we can turn our, in Germany especially, heating technologies into energy efficient homes and buildings. And this is also something what we currently do, and that was also motivating us to start the collaboration, especially with China a few years ago with our Sino-German center in Shanghai on eco-development of urban areas. Why did we choose that? Because we see that we have very many similarities between us two, although it may not be the first idea. In Germany, we have a very old building stock, which we need to renovate in the next years. We have a renovation wave in front of us in Europe, and this is actually the challenge we have in Germany. And I think also the large development we have seen in China in the past decades in the building stock will also challenge China with renovation. And also China developed several ways on constructing in a more industrialized way than we do in Germany. And I think that's a good exchange we can do, and what we also are experiencing. Because in Germany, we are very strong in regulation. What we did is in the 1980s, strong regulation on heating. And we did in the beginning of the 2000s, strong regulation on energy performance. And I think that's also one of the steps which China can see also in sustainable development of buildings, if we exchange our experiences in regulation. Especially when it comes also what also Mr. Zhang already mentioned in the life cycle analysis. With the Ökobau DAAD we have in Germany, that's the methodology we also develop at Fraunhofer IBP. And I think to to come to that transparency of sustainable values of building materials, on how to operate buildings, on how to share the operational costs we have along the building lifetime, we can bring this into regulative parts. And I also understood when I had correspondence with my Chinese partners that there is a very high fragmentation of rules we experience in China. And we need to have a stringent framework. And that's something we can share. And I think that's also of a very high value for the industry in that case, because they need to have a good planning basis on what to build in the next 10, 20 years. And then you need a very strong regulative framework for energy performance, for sustainable materials, for the carbon footprint we experience, etc. That's a perspective I think I want to bring in, and I think which is very important for the exchange between academia and industry for the next years.
Thank you very much, Professor Grün. We could hear you very clearly, and we saw you in the beginning, so if we kind of remember still how that looks. So actually, this is the perfect bridge now from the three industry and technology perspective we have. Now, let me ask the three professors to give a very brief sum up of the parallel sessions, and we want to start with Professor Zhao on the low carbon concrete structure. So please, Professor Zhao, the floor is yours.
Yes. Okay, Lucy. Okay, I'm the chair of the session 1. The theme of this session is low carbon concrete structures. Today we have 4 experts to share their valuable insights with us. The first speaker is Professor Jianzhang Xiao from Zhejiang University, China. His report gives the framework of sustainable design of concrete structures, aims to achieve the compatible system between the structures and the environments. The second presenter is Professor David Zhang from Zhejiang University. He tried to give the carbon emission reduction strategies for concrete structures in life cycle aspects. The third report was given by Professor Thomas Michelin from Aachen University. He thinks with 4 simple principles, the sustainable concrete can be realized. That is, work on the chemistry, reuse or recycling the materials, and build structures with less materials, and we should talk to the potential users. Okay, the last speaker in our session is Dr. Volker Thom from industry. He introduced a very new method to treat the construction and demolish waste called electrodynamic method. This method can separate the construction and demolish waste into different fractions efficiently to enable us to reuse or recycle the waste easily. So we have several questions left in our Q&A box, and based on these questions, the speakers discussed the low carbon concrete structure further. So that's all for our session.
Thank you very much. Yes, I understand we had all sessions recorded. So after you hear the wrap up and you're interested, you can still go and re-listen. So thank you very much, Professor Zhao, for keeping it short, but still even us, I could understand. So let's move on to Professor Huang Ming Fung. You were the chair of the second parallel session, Building Design and Construction in Climate Change. Please, Professor Huang, the floor is yours.
Okay, actually, session 2 was chaired by Wu Jingdong from Zhejiang University. So this session focused on building design and construction in climate change. As a short summary, the first 2 speakers from architectural design, they discuss more on natural materials and recycling issues. The Professor Kemp and Professor Yan, they discuss more from a structural engineering point of view. So in this session, I think it is a perfect combination of architecture design and structural design. So more in detail, Professor Ye Hao Song from Tsinghua University firstly introduced the innovative work of bamboo architecture. introducing 4 interesting and inspiring bamboo buildings. So the project reflects the organic combination of bamboo architecture with other natural building materials. So actually, bamboo is a wonderful natural material and is abundant in China. So the keyword of the first talk is bamboo, I think. The second talk, delivered by Professor Huang from Zhejiang University, he discussed the key elements and the process of building recyclability as a possible important solutions towards sustainable development. So he also proposed a guideline, so-called RE principles, for the design, construction, and operation stages of a building life cycle. So the keyword of his presentation, I think, is recycling, a key to building circularity. The third speaker is Professor Frank Kemper. Actually, he is my old friend from Aachen University. So Professor Kemp explained clearly a unique and innovative definition of resilient design. So particularly focus on the integrated design, both from architectural point of view and the structural engineering point of view. So he also highlights the safety of a building relies on developing appropriate mechanical standards and calculation, because we tend to make use of more natural material. So the safety issue still should be highlighted. Professor Yan-Li Bo from Technical University Brunswick presents a new composite structure. Actually, it is a timber concrete composite slab, as well as he demonstrates the wide application of this bonded skeleton wood concrete composites, and highlighting the advantages of different material, particularly the perfect combination of concrete and timber. So such combination not only makes the structure more light and reliable, but also easy to manufacture and construction. So the keyword of the Professor Yan's talk is, I think, composite. So that's all for my short summary.
Wonderful. Thank you, Professor Huang. And also we can see the recording of that second parallel session. Let's move ahead with Professor Ming that for the final session on low carbon construction materials. We already had some mentioning of materials, but I think you had some more very useful insights on your session. Please, Professor Ming.
Okay, thank you. And the third section is about the low carbon materials. And the first presentation is from the Professor Tai Jing. He is a distinguished professor in China from Hunan University. And his presentation is about the ultra-high performance geopolymer concrete. And as we all know, geopolymer is a very new type of cement. It's a new carbon cement. And it has a very good properties for example, the high mechanical properties and durability. But the low carbon cement still has very shortage in the future application. For example, the people concept is still concentrate on the normal cement, the Portland cement. So how to promote the application of this low carbon cement is very important for us. And I think for the researchers, we should concentrate on this. And the second presentation is from Assistant Professor Ran Shaoqing, and he is also my colleague. His presentation is about the research process in sustainable engineering materials in Zhejiang University. And actually, Zhejiang University have conducted a lot of new carbon binders and research on new carbon binders and the performance of new carbon concrete and the carbon evaluation. And he summarized the new process in this area in Zhejiang University. And the third presentation is from Professor Maria, and his presentation is about carbon concrete and its assessment from ecological perspective. And also, this is, I think we should highlight this presentation because normally a lot of the research is concentrate on the techniques. For example, how to develop the new carbon materials and how to use the new carbon materials in the real engineering. But this presentation tell us how to assess, how to evaluate, and how to evaluate the carbon concrete. And the fourth presentation is from Professor Victor, and his research is also concentrated on the carbon concrete, and he's from the Institute of Construction Materials, and we all know this meeting is about the green buildings and how to connect the new carbon materials with the green buildings is a very important thing. This job should involve a lot of researchers in the different disciplines. For example, the material science, the structure engineering, and the design engineering, and other different disciplines. So I think those four presentations are very important for the researchers to know the recent progress of new carbon materials and to think the relationship between material science and other science on promoting the new carbon society. And that is my summary. And thank you.
Thank you very much, Professor Ming. Indeed. So we have looked at the building sectors from an academic perspective, in different areas, the structure, the design, construction, and then also the materials. So thank you very much. Now we have 15 minutes. This is really not a lot of time because we have 6 speakers. I have a question that we pre-collected actually, and I would like to put my question to Professor Zhao. Because you were talking, you just summarized what others said. So my question was now your personal perspective on, if you can have 1 more minute, could you just tell me, what do you think is the biggest and most important gap we need to close in the field of low carbon constructions? Where would you put your focus on in terms of research for this issue? Please, okay. Yes, perfect.
Yeah, okay. For my understanding, this question is about construction techniques. Because we have already known the carbon emission in construction stage is not very much. It's only 2% of the whole life of carbon emission, mainly from the transportation and the usage of the machinery on site. So I would see that we should do the research work for the prefabricated structures. So if we use prefabricated construction, it is a good way to control the construction quality. So for our researchers, we should focus on the prefabricated construction method and try to use this method to construct the structures. So the carbon emission going to be lower compared with the cast in place method because the field work reduced. So, but anyway, you know, the carbon emission in construction stage is very little. So the low carbon construction, personally, I think will not influence the whole life cycle carbon emission of the structure very much. Okay, that's my answer.
Okay, yes, thank you very much for that takeaway. Switching to the next question, I think it's easiest for Mr. Zhang to answer, Zhang Shuhao. If you have also just 1 minute and you should just summarize from your experience comparing Germany and China, what is actually the advantages of the energy saving buildings in Germany and the disadvantages you think are most important? Also you, sorry, I just give you 2 minutes.
No problem. Yeah, I think I can do that. So, well, I think the first of all, in Germany, they have a very clear and dynamic energy standard, which is suitable for new buildings and existing buildings. That is actually very important. The standard will always increase and yeah, for existing and new buildings. And of course, nowadays for this EU taxonomy, they are also using that method to regulate which kind of buildings are sustainable buildings. And that standard is also dynamic. So in the whole industry in Germany, everyone knows I need to continuously improve my energy efficiency. That is the first good thing. And the second good thing I think in Germany is that they have a very competent GC team, general contractor team. In that team, they also have engineers. They have a lot of engineers, not like in China. The GCs, they are only constructors. They don't understand really what the technology behind is. So yeah, I was personally once a site manager in Germany, and I was really impressed that the drawings, the as-built drawings from the GC team is really good. You can really compare this one-to-one with the site. So the disadvantage for Germany, I haven't found one, but I would say in Germany, because it is relatively small from the area point of view in comparison to China. So in Germany, you only have a limited climate zone. That means the experience in Germany might not necessarily suitable for China. Now in China, you have in total 6 or 7 climate zones. You need really to adapt these advanced technologies from Germany to China.
Well, thank you. Thank you very much. Indeed, Germany is very small. And that's also why we think it's so important for us to cooperate with China, because it doesn't matter what we do in Germany. It's actually much more important what happens in China. So maybe I can ask Professor Huang, is there an easy, a tool of 1, 2, 3, 4, 5, how to improve building design for sustainable development? Can you just say, these are the core things, always think about that, and that will solve 50% of your problems? Is there something you can give us in a short wrap up, also just 2 minutes?
Okay, thank you. So actually this program already discussed in para session 2. So in that session, 4 speakers provide very important different perspectives for sustainable building design, from architectural design point of view, from structural design point of view, and recycling as well as resilience. So all this should be combined together. I think I would like to emphasize here is we need a holistic approach to sustainable development. That means we should bring building material, manufacture, architecture, and structural design, as well as construction and operation all together. Actually, we do have a chance to do that because, based on the latest building information modeling technique, so-called BIM technique. So such a technique try to integrate all discipline data into a one digital computer model. So such a uniform digital basis and tools not only can be used for the planning and the design phase of the building, but extending throughout its life cycle. So in addition, climate change already exacerbates the natural hazards. As you know, we have stronger typhoon, more extreme rainfall, storm surge, and flooding more frequently occur in China and all over the world, and making huge damages to buildings in recent years. Actually, our recent study found that if historical super typhoons in Southeast China were to occur at the end of this century, under the higher greenhouse gas emissions scenario, they would have on average a more than 10% increasing in wind speed, as well as more than 20% increasing in precipitation. So I think from a structural engineering point of view, because I'm a structural engineer, so we should study the possible change of extreme weather-related hazards and cope with the increasing natural hazard risk. So as highlighted by Professor Kemp, because it is a risk we cannot ensure absolutely 100% safety. Okay, so, but we need adaptation. Okay, that's all for my.
Yes, thank you, Professor Fung. Indeed, so it's not only important what happens, indeed, also China is experiencing very, very strong effects of the climate change in flooding, in extreme weather, indeed. So I do understand that also in China, there's a very, very strong push towards adaptation and to actually do more research. So that also brings me to the next question. I think, Professor Green, you're still with us. I still cannot see you, but I hope you're there, because that would be my question. If you could say, what should the Chinese-German collaborations emphasize? What should they do in terms of joint research and development? What will you prioritize? Could you just give me 2 or 3 areas? Thank you.
Yeah, I'm still with you. Thank you. Sorry about that video. But yeah, I already heard several things from the previous speakers where I fully agree on these topics. As I mentioned before, I think in the joint research, we both have the same challenge that we have to bring our building structure to sustainable building structures. So I see that we would need this regulatory basis, which we mentioned that is quite well developed in Germany. We're still developing it further at the moment, because we need also, because of climate change, to include cooling, which we do not have so far in Germany. We concentrated on heating in the past, which is also not the only thing for China, because China has very many climate zones, as we heard already. So I would say that would be a very important area to come up with a good plan to develop energy efficient buildings, to include the production of renewable energies into the building and energy distribution. That's the one point on the regulatory basis for energy use, energy efficiency, and life cycle analysis. It's the parallel to what we do in Europe. And the second part is on how to reuse our building materials. We are short of materials at the moment, and we have extremely increasing prices because we have no access to sufficient building materials. So we need to see how can we really recycle, not downcycle, our building materials. And that would be the second large point, which I would put emphasis on joint research, so that we can construct, also sustainable buildings. Because I think as we building more energy efficient buildings and more use of renewable energies, also the carbon footprint of our building materials will increase from currently, let's say, 10% to 30% of the building lifetime. And that's why I think it's extremely important to build on recyclable materials also in building construction.
Yes, indeed. Thank you very much. Indeed, we're discussing the shortage of resources and materials a lot in Germany nowadays, but also in China, I see that there's a big push for the reusage of materials. Ladies and gentlemen, I will finish on time. I would like to put one more question maybe to Christian Zama, because you are in contact with the German companies, and you already said we don't have any construction companies anymore in China, though we used to have them. A lot of actually airports and buildings were built in the 90s and the beginning of the 2000s. But now look at the companies now in China. Which type of companies, which sectors do actually have a chance to make the biggest contribution in terms of low carbon and the transformation of the building sector. So if there are some top companies, which ones do you think will make the biggest impact here in China? Could you just give us maybe a sum up, and then I will just close up today's forum.
I think in general, it's the planning and the architect. And I think Mr. Zhang from Dresden Sommer and also the others, but Mr. Zhang from Dresden Sommer pointed this out that clearly. If the planning is not detailed enough, the construction workers and the managers on the construction site do not know how to do exactly right. And then the joints will be not correct, and there the emission is extremely high. So we can see it, and that's a second point. Also, first of all, planning, architect, that's very important contribution. Second is we have to see, as already said, China, everybody knows, is huge. So of course, Shanghai, you can pay more as a landlord or as a tenant. So ultimately, you can ask for more quality. In the other area, which we don't forget, that is 50–60% of China. We could really very easy, with a very little money, we could upgrade the existing buildings just to insulate there a little bit more. It would help a lot. This is the second, I would say, biggest impact Chinese and German companies and corporations could do. The third one is standards. We have to set standards for new buildings, which are clearly China-wide, but of course taking into account that, as I just said, the development in Shanghai is different than in other cities. They cannot have the same regulations. So this will be also very important to basically have a China-wide concept, not just only for Shanghai or Beijing, just a China-wide concept to get everything much better. Don't forget basically the customer. He has to pay. And if the standards are too high, if the construction costs are too high, there will be no new buildings or very little. The contribution therefore, even your plan super good, is very minor. So that's why focus on the existing buildings. Don't build too much. And a building which is half empty will never be energy efficient in an operation point of view. Thank you.
Thank you very much, Christian. Also, thank you to the other speakers. I mean, I'm very sorry as a co-organizer together with the Zhejiang University and the RWTH Aachen, what we normally would do now, a big applause, of course, but then also we would just continue talking with a nice beer. Okay, in Germany, it's not a beer time yet, it's noontime. Well, with a nice meal. This is what we normally do. Okay, you have your beer now here. Okay, but this is, I'm so sorry. This is actually the limitations of the digital meetings. Of course, on the other hand, we are very happy that we could, through the digital meeting, we could invite very distinguished speakers. So once again, thank you so much from the bottom of my heart. I also thank you for the professors and the researchers contributing in the parallel sessions. I want to thank the organizers. And I say greetings from Beijing. Hope to see you next time in Hangzhou. We all love to go there, no matter whether we come from Aachen or from Shanghai or from Beijing. From the bottom of our heart, thank you for this nice afternoon. Have a wonderful weekend and hope to see you soon. So thank you very much from my side to everybody. Thank you.
Thank you.
Yes, thank you as well.